The Earth is very flat.
What's going on, everybody? It is Monday, August 30th, 2021. This is Brandon, host of Brandon Show. Hope everybody had a good weekend. I see quite a few people in the chat already. We've got Gadget Inspector, PJ Cruikshank, Cleary, YouTube, Alexander Lightwater, Arwin, Shilvy Shills, Brian Leakey, Brandon Cook, and let's see here, Fuzzy Bushmonk. Page 42, Dan Morris. What's up, Dan? And let's see who else. Paul Baker says you can go ahead and cancel the show. The Earth's not flat. You're welcome. Thanks, Paul. And PJ Cruikshank was first. What's up, man? No problem. Shouting out your friend Harry. Hope he had a nice birthday, man. Not a problem. Rob Keene with a super chat. I can't join today, but I will be listening. Have a great show, Brandon. Lost headphones. Oh, shit, no. That's an emergency, man. You got to get to the store immediately and get some new headphones. You can't go a whole day without headphones. No way. Thank you, Rob. Appreciate it, man. All right, let's see who is in. Sounds good. Thanks, Bill G. We've got a bunch of people in Discord already. Let's pop in and see what they're talking about.
Flattened stationary surface rings fucking Big Ben size bells, especially.
No, actually,
you just told me.
That's where you're wrong, sir. Most of my worlds are set in a flat stationary plane, or at least a flat plane on some kind of creature's back.
Excellent. Why would you do that if it's not representative of reality?
Because it's funny.
No, hang on.
The
polar Earth argument is in general. Well, every other space body from the moon to the furthest star is spherical, and the Earth isn't. The Earth is an exception. Hang on. Every video game that you are involved in, or pretty much every other platform,
I play video games.
Revolves around a flat and a stationary surface.
Yeah, and it's turtles all the way down.
Why is that funny, though? Did you not agree the last time that that's all you experience is a stationary surface as a living man?
No, I actually asked you a question that you were unable to answer.
Hang on.
My question to that is
question,
what? Okay,
hang on.
go ahead.
Before you re-ask that question, Kool-Aid, let me re-ask my question. So it is, do you agree, or does anyone in this panel disagree, that as the living being, and by extension, that everyone who's walked on the surface of this earth has only ever experienced stillness, relative stillness? So that's the question.
So
say the question one more time.
Do you agree that everyone who has ever walked on the surface of this earth has only ever experienced relative stillness?
You mean in reference to the rotating earth?
No, not in reference to anything else. In reference to our own.
Right, but we're not talking about these people got on an airplane.
Well, imagine you were on the stand then. Imagine you were on the stand. If I was to push you for your dying fucking thoughts on, if I asked you that question as you were dying, you have to tell the truth. Are you going to get to heaven or hell? What are you going to say throughout your whole life?
So if you're asking, can I detect the Earth's spin at 15 degrees per hour with my?
I'm not asking that. Whoever's coming in there.
No, I can't.
That's beyond that. That's the next question. I'm asking you.
So be specific.
So, right. Yeah. What are you asking? Yes, I've been on a sailboat that has motion.
Do you agree that in your life experience, that, and everyone else by extension's life experience, that we all experience a still stationary surface Earth? When we're moving, it's in relation to the stillness that we all cling to.
In that reference frame, yes.
In your real reference frame, right?
And
the other reference frame, you have to hang on. The other reference frame you're talking about is your mental reference frame.
You literally interrupted me to go on this diatribe
but
to explain to me what I was saying.
Okay, man.
Let me explain what I'm saying. Okay. I'm a grown-up. I can talk for myself. I don't need you.
Brandon, save us.
According to the reference frame of the spinning Earth, I would agree with you. I have never felt it. Right. I also don't expect to, because my vestibular system my body does not have a mechanism for detecting maintained motion.
Right, but I
What-
never asked that.
Yeah,
All I asked
begging
was a
the
yes or no
question.
answer. Simple.
What's going on,
Considering
everybody?
consequent begging
Hey,
question.
just let you know
All right,
we are
Brandon.
live on YouTube. Sorry to interrupt the conversation there, but I don't
Thank
want to have
God.
another conversation, the millionth conversation about the fucking vestibular system. It's too early in the week for that shit.
You're lucky then, Brandon, because this is about Earth's turn, and Kool-Aid here has just said he never experiences, through his own direct experience, movement of the Earth. And my point was, that's yes for the question I asked just before we came on air. Therefore, the movement of the Earth is incorporated within your mind, and within your mind, all manner of possibilities become available. I can imagine a woman with 4 breasts and one hanging from her left thigh, for instance. Imagine.
Oh my God. Brandon, save us, please. Please.
Oh, Pete, I love
please.
it. I do get
Did you
your
say-
point, Pete, though.
Thomas said, please, as if that was a perfect vision of a woman for him.
Yeah. No, I get what you're saying. Absolutely. So if you've never experienced it, then he's right. It is in your mind. You have constructed something somehow, whether it be through evidence or your interpretation of evidence, to tell you that the Earth is moving. You've never experienced it. Oh, that's true, but we can argue about that later. So, how's everybody going? How was the weekend?
About that.
I see we've got
Pretty
Billy
good,
Sanchez.
Brandon. How you doing, man?
Good.
Good to
What's
see
up,
you on
Brian?
Monday. Good to hear Pete Shea back these last couple days, man. I went to a couple of his streams and put out the invitation a few weeks ago. I was wondering he showed up, man. Always a pleasure, Pete.
Hey, Brian.
Yep, absolutely. Yep. He came back on Friday, I think it was. Awesome. We got Chad, Chikey, Conrad, Contain, Helium Live, Drink of Kool-Aid, Enigma, FE Self-Evidently, FE Walker, Geo, His Ether Bandiness, I'm not even going to pronounce it, Pete Shea, Carnivore, Left Lane, Linotomo, Matrix Media J, Paid NASA Shell, who's already muted. What'd you do, Paid NASA Shell? Bill Nye, RC Meisty. Thank you for joining the panel. Please have a good open discussion. Passionate discussion, but do please be mindful of the other guests. We've got a big panel, so share the mic, and please refrain from interrupting on a regular basis. And I'll try to do the same.
I'd like to get this out of the way then.
Hang on,
if
Brian.
possible.
Hang on, Brian. Let me just finish off the point, right? It might be a lead into a good extension. But my point was to Chikey and Kool-Aid. Right, if we establish that as a fact that we can all agree on, a universal truth, that the Earth that we experience in our lifetime never moves, well then we can understand that the ball never comes into play. So when someone talks about what about the 15 degrees per hour movement? What about different things? That's an extension beyond the initial assumption, which is that the Earth itself moves. So it's a killer sort of point. But off you go, Brian, and just want to finish that off based on the previous comment.
I wanted to just say real quick, man. I made a video to point out. I think this video has been made on several ballers doing this, but they don't understand when they speak of reference frames. So I made a little video about biodual. It wasn't nasty, but it was just in hopes he would watch it. It's just about 2 minutes long of him speaking about the reference frame and talking about Coriolis and speaking of how the Earth in the atmosphere are one reference frame, and then immediately 1-2 sentences later him saying that the plane is leaving the reference frame. I mean, they don't even understand. I've tried to point out that, and he's obviously doing it on accident. He didn't even understand that in his own mind, he's considering the Earth and atmosphere as one reference frame, and then consider him as 2 seconds later. So I pointed that out in a little short video on my channel, Flat Earth Test, as y'all know.
Yeah, you got to be real careful anytime someone starts talking about reference frames, especially when they're talking about Coriolis and plane flight, because they can confuse people very easily with that shit.
Brandon, something.
Well, the one thing, if I could just jump in real quick, I was looking on YouTube some lectures on Coriolis because I was really interested in of it, and one of the lectures that I came across didn't talk about the so I had to do this. So the reason why I think last week we had some conflict and the apparent election of Coriolis was because this guy was using.
Hold on a minute, Travis. You're roboting pretty bad. You're like cutting in and out. And Effie, your mic's open.
All right, is it better?
No, it's like every other word is
All right,
chopping out.
Hold off. Okay, I'll hold.
Okay, all right.
Travis in transit for you.
Yeah, we could almost understand what you were saying, but I think starting to miss some critical stuff there. So we can talk about it again. I see Allie B just joined us. What's up, Allie? You awake? No. All right. Anyway, I wanted to start talking this week about.
Yeah, I'm here, Brandon. Yeah.
Hey, what's up, Allie? How you doing?
Not so bad. I was just going to say, Travis, he should give Brian his microphone back. He's missing it. Sorry,
no, he's
Brian.
still got it, Allie. I just heard it.
All right, okay. Sorry, mate. Yeah, I'm here.
Your own microphone isn't great, to be honest, Ali. Brandon asked, are you still awake? I'm sure you are. You're probably still drunk, though. He didn't ask that question.
No, I'm not. I'm not drunk.
Ali?
I'm driving. No, I'm driving. Not so bad, Pete. No, I'm driving. Well, I'm not driving at the moment. But I'm driving down to Brussels at the moment, sharing.
You were driving riding a motorcycle or what?
No, in a lorry. I'm driving a lorry down to so.
What's that, a truck?
He's actually driving a load of drugs over to me in Ireland here, but he doesn't want to say that in there, just in case it compromises us.
Oh, I see. Okay. I wanted to start. What's going on?
All is well, man. How are you guys doing?
Good, Don. I want to start talking this week about some perspective things that I've been looking at and show you guys a couple of observations about how things look in the real world and how we potentially have been mistaking, well, not we, but some people have been mistaking an aspect of optics for
you
Earth
mean just
drop.
me? I'm just kidding.
Yeah, just Grim. So
Just
it's all
me,
about
man.
Grim. But I want to start off with Don. Since you're here, you showed me something really cool over the weekend. And I think it might be good to start off with that and talk about that if you don't mind. If you're able to.
I'm gonna love this. I'm gonna love this.
Are you?
Oh,
Good.
you might
I'm
actually.
quite sure, based on past experience. Yeah. What did Don tell you?
Well, it's the Michelson Morley experiment with the interferometer. The guy does it in a horizontal pattern, and there's no interference. But when he switches it to the vertical, there is an interference at 180 degrees. Like, so start at 1, it goes counterclockwise, and then when it keeps rotating, and it goes in reverse counterclockwise at another 180 degrees.
Yeah,
That's
so
the whole
I've got
point. Yeah, it
I've got the
doesn't-
video up, and you can see he's got this set up. He's kind of showing
Does he
his
post his latitude and
interferometer here.
longitude? Of course he does.
Right. So he does it.
Okay.
I'll just show you the different parts here. He's got it on this stand. He's going to spin it around like this. Shows the interference patterns. And then he turns it. This is the part that I found interesting, and I couldn't really wrap my head around it. I didn't spend too much time thinking about it. Is he's doing it vertically, and he gets an interference pattern that changes direction as the interferometer rotates. So when it's 180 degrees one way, it goes one direction. When it hits 180 the other way, it changes its direction again.
So is he moving towards the north right now and then again towards the south? Are these like, that would be interesting to know. Like when they get to that point where they seem to stop for a second, that little mid-range point, is that north or south? You know what I mean?
Well, he didn't give all the great details of it. He didn't assume or nothing like that. The fact that we are witnessing that there is an interference allows us to know that, you know, this experience or test could be done again with more great detail.
Now the point is their interferometers do not pick up Earth curve. Like if you're in a plane, an airplane traveling, okay, physical gyroscopes as well as the laser-based gyroscopes don't pick up Earth curvature. They don't show us pointing down and around. They point to a horizon or an artificial horizon, however they want to say that. They do not pick up Earth curve. They wish it did. They try and obfuscate, but when in a plane, okay, they do not pick up Earth curve. Gyroscope, any kind of gyroscope.
Let me say something briefly, but it definitely
Well,
involves.
no shit. That's not what gyroscopes. That's not what gyroscopes are meant for.
That's what
So,
no
you
one's
guys,
arguing
anyway,
with
back
him,
to
so
this.
just leave it alone.
Yeah.
So he's got this
let me just say
vertical
something.
interferometer that
water
he's
is
spinning
wet,
around.
and that is it.
Right.
Okay.
Well, didn't I get in first here? Let me say something very briefly, which might lead to sort of a deeper conversation. But one of the questions I've been asking over the last few years is why, in reality, sort of gauging sense, why are the undersides of all clouds formless, whereas every other?
So why
side?
are we taking? No, let's not take
Can
the
I ask?
discussion
Can
away.
I speak for more than fucking
No,
30
Brandon.
seconds now?
We're changing the subject, though.
It's all right, Travis. I got it, Travis. I got it.
Right.
Come
Go
on,
ahead,
man.
Pete.
Let me just say, I was only going to fucking say it for 30 seconds and go on mute. My answer to that, or my thinking regarding that, I've been asking the same questions. Why are the undersides of old clouds formless, whereas every other side is of form? And my idea is that the ether comes from above, so it's a sort of vertical emanation, right? So if you point some sort of instrument upwards, you will get a certain pattern reflected, and if you point it horizontally then crosswards, you will get that interference pattern to the greater emanation. But again, that's a question for later on, and I haven't seen the video in question. So thank you, Travis, for letting me one sentence get out. I got 5 sentences out, and I'm done now.
Has anybody ever seen this conducted in this way? Because usually when I see it, Mickelson and Morley, they did it on a table, did they? They didn't do it like this.
I mean, the biggest Mickelson Morley was like across a huge freaking, what do you call it? Like a big warehouse.
Uh-huh.
I heard 200 yards. I heard 200 yards for each arm. But Peyton, that's a shill. Why would none of the gyroscopes detect the Earth curve if it's changing it? If it's rigid in space, okay, meaning gravity, you know, it's made to work against gravity. Basically, it holds its rigidity in space. Why would it not pick up the Earth curve if we're traveling around a ball?
Brian, honestly, why the fuck are you asking him a question?
Yeah, white.
Because I'm just trying to expose him. I wanted him to answer it out loud. I wanted to hear him. I want
to hear the same answer that all the bowlers have given over the years.
White's word has been proposing a test of a gyroscope, driving it across Australia or flying it across a section of Earth to see if it detects the change, which it should.
They don't claim, Jeremy, they don't claim it detects it. That's what I'm trying to point out here. To me, this is the best flatter proof there is the
Maybe
fact that
Chaiki just doesn't understand what you're saying.
What does that got to do with this, Brian? I'm failing to make the connection that you've made somehow.
I'll back off.
No, it's okay. I'm just wondering what your point is.
I got in late. What is this? A vertical interferometer?
No.
Yeah.
Does it rotate on a mercury bed? A bed of mercury? Does it rotate on a bed of mercury?
I don't think so.
Because that's what they did, right? They had this turning surface float on mercury, and they would rotate at 90 degrees, right?
Yeah, I think that's what I remember. Yeah.
Well, my first assumption.
Does the mercury move too in a one direction?
Yeah, but hang on.
Wouldn't that induce a current?
Let me ask Brandon. Brandon, are you asking this question generally for bowler who's to respond? Because if
No, I'm asking for anybody who can explain why we're seeing an interference pattern when you turn this 180. If anybody knows, has seen this before, or can explain it.
Well, My
Can
first
you
assumption,
post, can you
I had to
post
do it
him
real quick.
the
over the apparatus.
That
Brandon
thing,
asked me.
three people's interrupted Brandon before he got his damn sentence out.
Yeah, Brandon,
I
can you
got
post the link?
Hold on, goddammit. Brandon did ask me a question. I got disconnected. The thing is
You robotic, Brian.
Your connection is fucked, Brian.
There
You
is-
should reconnect and reconnect, man. Honestly, no one can hear it. Let's just say to Brandon. So if it was to Brian, there's no point in asking a ball earther for an explanation as to what's going on. Then we're looking for the reality explanation, and that's why I mentioned what I had to mention there. If there is this vertical ethereal force from above, right? If it's in a vertical direction, as you measure anything in that incline, you will get a certain result. And as you mentioned, as you measure anything across that, in potential anyway, in thought process potential, across that incline, you will get a different inframeter reading. That's my point there.
So okay, that's interesting. I see what you were getting at. So Don, what do you know what's causing this interference pattern? Can you just describe it? Like, what is going on with the lasers that causes this? Not what causes the change in the lasers, but what is physically taking place?
I'm not making no claims because I don't have full detail of his latitude and longitude. I would say the electromagnetic field, but that's just
No, I'm not looking for a cause. I'm not looking for a speculation. I'm looking for what is the explanation? What is happening with the laser, the contraption that is producing the interference pattern?
I have no idea, Brandon. That's a great question, and that's why I brought it to your guys' attention.
Okay.
Everything in the way of that.
It has to be a frequency. It has to be a frequency distortion. It has to be because we have a level line reading and we get a distortion from it because you're firing something at it. It has to be along those lines.
What's the laser going through? If it's going through a glass medium or any medium, it's going to have a source of like energy coming back at itself from that source too.
Listen,
No, it's just
there's two
shooting on
kinds.
some
Okay,
mirrors.
you got the relay, you got relayers and enterprise.
He would have to
Yeah, you got
take
the
all the
relayers.
electronics. He would have to take all the electronics out of the room, is what he would have to do, and isolate that because there's magnetic and electric field just from the wires in your fucking walls and shit that can interfere with.
Are you talking about Brandon, about how it
coherent light?
How it interferes? Are you talking about how it interferes with itself, like canceling itself out by a high and low trough coming together? By high and low frequency coming together to cancel each other out?
Yeah, just
that
what
works.
causes
I
the
mean,
interference pattern. Period. Not.
Yes.
Not.
The explanation is the explanation is if you take water as an example and you have the same diffraction, you'll see the elevated signal is doubled by having the trough amplified because it's the same frequency, and then having the frequency cancel out because it's the opposite of the trough, right? That's how the water example displays it.
Excellent, man.
So it's equating it as a physical interaction.
Swim. It's like you go into a stream that's moving and you swim across the stream, or you swim in either direction against the stream or with the stream. So when you talked about that,
And not only that,
Hold on, he wasn't
not
done,
only
Brian.
that, a stream you could never show motionless.
right, but this is where ether comes into it, and this is where my question about the underside of clouds. Why are they always formless, friends? How many of my friends are they flat earthers? Why are they always formless? If there's something coming from above, and it will affect all sides, but not the underside.
I can tell you about the clouds later, but I want to table that because Brandon brought up a really good point. That the idea of clouds that has to do with air pressure and condensation points. I can talk to you about that later. Has nothing to do with
And electric fields.
Brandon,
ether,
they have
It has
never
very much to do with electric fields. Don't try to cloud your way out
I'm
of
dying
this.
to get this one point out, people.
Hold on, Brian.
Dying
Hold
to get
on.
this one point out.
Guys, hold
Hey,
on.
hold on one second.
Brian. I know you're dying, but RC was in the middle of saying something, I think.
I was just.
Your mic's fucked too. Brian, your mic's fucked.
I was simply saying, Brandon, in order to respect your good question, I can talk about the bottoms of clouds later. It has to do with the pressure that is happening in the atmosphere and the layers of those pressures, the condensation point of air. It has nothing to do with anything other than the pressure differential that exists.
Let me just comment very
You were
briefly,
just saying
Brandon,
later
to
I'll
that,
talk
and
about
I
clouds.
will go on
Okay.
mute.
Yeah, you're not going to have
let
that
me
going
very
on
briefly.
without electric fields.
Okay, I know there's lots of people trying to talk, but let me comment very briefly on that because I mentioned the topic, right?
Brian, go
Let me-
ahead.
sorry,
Hold on,
Brian.
Pete. Hold
I'm
on,
just going to
Pete.
speak for 10
Hold
seconds
on,
because
Pete.
They have never shown an
Brian.
interferometer with. Yeah.
Go ahead.
Interferometer without interference. They have never shown an interferometer without interference. So if they wanted to try and rotate it against the grain to show us no interference, to show, hey, it's the Earth spinning, or against the ether, whatever you want to call it, they have never shown an interferometer without interference.
That's the whole point of the interferometer, Brian. That's the whole point.
There's interference right here in the vertical,
Come
though.
on.
So can you explain
Brian, you're
that? I'm
dealing
trying to
with
figure
all
that out.
earthers here. I'm dealing with real questions. But with RC there, when you mention that about you're going to come back to it, hopefully you will. All I will say to you is when you come back to it, remember the basic laws of physics are water in all its forms.
I know the basic laws of physics.
I
Why don't
finished what
why
I
don't we
said.
allow them to have their
Excuse
actual
me.
conversation?
I finish, please.
It's
Just gonna
completely
speak
off topic.
15 seconds and I had to interrupt. Now I'm the bad guy because, this guy is shouting.
Yeah, you're the bad guy. You're the bad guy because the topic got tabled and you brought it back on the table, man.
What the fuck, man? All I wanted to say to RC when we get back to the topic later is that.
Oh my God, wait till the topic comes up later.
Wasn't finished my 15 fucking seconds, Travis.
Oh my God, why?
Can you just shut up? We will talk about it later. Let them
Let
have
me
their
say what I have to say on that matter because I brought it up,
Shit.
right?
Guys. All right, Pete, just
Brian,
hold
I
on,
brought
all
that
right?
up, though,
We'll bring back up the clouds if it doesn't have anything to do with this.
Let me say one thing. Let me finish my 15 seconds for God's sake in response to him. Right. Clouds defy the laws of physics. Water takes the path of least resistance, as
Fuck
does
Pete.
every form of water. In its particular form,
Anyway. Yeah. Pete, you're being pretty relentless, man. So can anybody explain why it would in this vertical position? Let's just say that this is done properly. All right, just for the sake of it. Why would there be this interference pattern on, say, a globe model? What's the official explanation for this?
I could guess that the light is polarized. Can I have the link, please?
The light is polarized?
Yes. Can I have the
Explain.
link, please?
Yeah, I already put it in the general
Polarized
chat.
in a certain orientation.
What does that mean? Explain. I don't understand.
They can't
What's
say
the
ether.
light being
That's what
polarized
they
have to
can't
do
say
with
ether.
the globe? I don't understand.
Doesn't have to do with the globe, the interference. Can I have the link, please?
It's in the fucking general. I already
No,
posted
it
it.
isn't. No, you posted
Yes.
chat
Hey,
or something.
hey,
No,
Brandon,
The wrong link.
this is pretty cool. Brandon,
Wrong link, Brandon.
Hey,
Wrong
Brandon.
link.
Hey, Brandon, this is pretty cool. How big is this machine? Do you know?
No, I don't know.
Okay.
I mean, I
Doesn't
think
look
there's
that
some. I think we can get some scale. Yeah, he stands next to it, so you can see at least.
Okay, so it's not that big. So probably like 2 feet long. Okay.
2 or
cool.
3 feet. Yeah, something like that.
That's great, but see, the thing is, nothing occurs. There's no interference in the horizontal. There is in the vertical.
No one has an
Apparently the light-
explanation on the globe for why there would
the
be
light
this
is not-
interference pattern, or Chikey's going to go off and look at it and let us know. Is this not something that has been ever discussed before? This vertical interference?
I'm finding a couple of references to it, and I posted one of the articles that's pretty dense. And I'm driving right now. I just stopped for gas and then posted the article that I'd seen before on something like this back in a couple of physics classes. But I don't know enough about this experiment to dissect it. But I did post an article that does address it a little bit.
We should have thought about that in
What are you talking then?
vertical versus horizontal.
All right. Well, It's interesting. It's out there. Take a look at it. I guess.
Yeah, definitely.
No one
But there's always gonna
knows
be a
why it
resistance,
happens.
Brandon. Well, there's still a resistance, even vertical. Maybe not as much at all, but there's still a resistance. There's something you have to
They need
practice.
there to be a background though. They really need that, but they can't state that. So Brandon, good job simplifying shit and breaking it down, dude. You're so good at that, breaking it down to the simplest points and listening to them fumble and disappear and shit.
Mickey, do you
Got to get for that.
Well, Don brought this up. I'm just curious why it's happening. I've never seen this before.
I'm just saying to Brian, do you understand if you're looking for answers from the usual crowd that you've looked for answers from 1,000 times before and you've never got any answers, well, you're going to get the same process for the next time. When I ask my questions, I'm asking my questions of flat earthers. That's all, which is to try to describe what actually is fucking happening. We know what the ballers will say.
I didn't specify any flat earthers or ballers to begin with. And then I'm curious, what is the official explanation? What's the explanation that we're given for the interference patterns horizontally that Michelson and Morley did?
Do you think the explanation is for this?
And how does that apply to this vertical position?
About sharing ideas, right? What do you think, Brandon, the possible explanation might be?
I think there's some kind of field that is interfering with things on the ground, probably emanating from multiple places, perhaps the sun, the moon, who knows what else.
I would say because that's a regular. Because that's a regular. Because that's
He does.
Regular, can I just say this, Brandon, please?
And light, the reflection can go through the light into the water, like off water. I'm sorry, light off water.
I know.
Hold on a second. I can have my hand.
Because it's a regular deviation. Because it's a regular deviation. I bet my life it's a regular deviation in the experiment showing that. Then we can extrapolate and well, what? Imagine that we're going through a field of something. Every field has a direction, right? And what were you going to say? An intention, a source, right? But as we're going, as we're traversing, as I gave the example of traveling through a stream crosswards versus in the direction or opposing direction of flow, then we might expect these regular distortions.
Light can reflect.
Right. Well, if I can make a point real quick. He does get different readings on different days. So, Brandon, to make a point when you said the sun, the moon, and all that, yeah, big factor. But the fact that we're observing in this in vertical shows that there's a phenomenon that we could test more, more.
So,
Since I just
when I was in college, I remember talking about Michelson Morley, and one of the reasons that they didn't do this on a vertical plane was actually because of differentiating air pressure. So as you go up,
it propagates upward. Yeah.
So the differing air pressure as you go from sea level to even 3 or 4 feet up in the air, it's enough to like mess with interferometers, especially that are really precise. And so one of the reasons, like as you go from one day to the next,
Hold on, let him finish.
So from one day to the next, you're going to have different, actually like differing pressures. And on a vertical plane, you don't get that differing like pressure gradient, whereas on a vertical, you will get a differing pressure gradient.
Wait a minute, the interferometer is not changing orientation besides vertical. It's still in the same position. The interferometer is not that's not what's spinning.
Hold on a second. Things come from the ground and go up.
Well, yes, the whole thing is, but it's still in the same fixed orientation.
Hold on.
So it's spinning.
So pressure slows down light. That's what he just said.
No, that's not what he said.
Pressure affects light.
Was that the differing pressure and the densities of the air as you go up, even 3 or 4 feet, can affect how interferometers work. So if you go up 3
There's
or 4
no
feet,
moving parts. There are no moving parts in the interferometer.
Let him finish.
There are no moving parts.
The light is moving.
If you go up 3 or 4 feet versus down 3 or 4 feet, you're going to have a slight pressure gradient because there's a density gradient.
What about the location of the star to your telescope?
Hold on, Pete. Fuck, you guys. Go ahead, RC.
And that differing density gradient will cause kind of messed up, especially if you go from up to down and down to up, like this is doing in a vertical axis. One of the reasons Michelson and Morley didn't do that, because you would have two different readings going in different directions, even
So
with
let
the
me
4 or
ask
5
you
minute
very
difference.
My question very briefly.
That's what it already does.
Please
Yeah.
add,
If
let
it
me ask
wasn't a sealed
very
device,
briefly.
how would you know the pressure was different?
Ask this question very briefly. When you view stars through your telescope, then, RC, is there not an equivalent distortion? Theme of light, right?
If you're looking up, you're going from dense to less dense. If you're going down, you're going from less dense to more dense. That's kind of the point of why Michelson and Morley didn't do this vertically very often, because you have that when you're trying to shoot the light back and forth, right? You're going to get different readings in different directions.
Did they go up? How far did they go up to know that it was a certain constituency? As far as I know, that was before the beginning of the 20th century.
Yeah, and we still knew about the pressure gradient well before the 20th century, and the density.
You're asking the wrong question.
There was infinite space beyond, or did we assume it?
No, we didn't assume anything. We knew that there was a density gradient in the atmosphere, and that affected how light travels through that.
But you extended it.
Hold on,
You extended the
Pete,
atmosphere.
Pete,
Let me just
give
say
me
this,
1
Brian.
second,
Let me
man.
say this,
For
Brian.
God's sake, Pete.
You extended the atmosphere,
You're
right?
asking the wrong questions, bro. You're asking the wrong
Brian.
questions. So hold on. So,
Let me just say
Meisty,
this.
is there
One
more
question.
humidity?
I'll go
Is
on
the
fucking
humidity
mute then,
down
Brian.
at ground level? Is the humidity down at ground level affecting it too, Meisty? You say the pressure is affecting it, but if it wasn't a sealed device, you wouldn't know the pressure differential, except for just assuming it, which is fair to do. But is the humidity down toward ground level affecting it too, Meisty?
Yes, water in the atmosphere can affect how light travels. Yes.
It's even denser, Brian. Good point. That's even denser than looking straight up, because you have an equivalent level all the way.
Water in the atmosphere makes it less dense, not more dense.
Okay, so that's one possibility. I mean, so far the evidence you've provided is that Michelson and Morley decided not to do it in this orientation because
You're saying it's
of the
Brandon,
atmospheres.
he's saying
Hold
it's more
the
water than
fuck
less
on,
water.
Pete. God damn. Is the density layers in the atmosphere. So they were, I guess they were afraid that would throw it off. So that does make sense. It's a possibility.
Yeah, I mean, I do remember them citing that. Even when I was reading about Michelson and Morley in college, I remember them talking about their setup and how we didn't do it in a vertical column, because even 200 meters of a vertical column, you're going to get a significant gradient and a density gradient.
Hang on.
Can I just get you? Hold on, Pete. Can I just get you to say again that you said when there's water in the air, it's less humid or less dense or more dense?
It's less dense. Less dense.
Yeah, hey, that explains my refraction gradient, guys.
So when you put water in the air is now less dense than other air without water?
Water vapor is less, yes. When you have more water.
That's why light refracts upwards, guys. That is why light refracts upwards.
Would you like to know why? Would you like to know
That's why my refraction model works, because of moisture.
You don't have a refraction model.
Hang on, please. Can I ask
Jeremy,
this one question, please, Brenda?
Jeremy,
Hang on, please. RC, you're saying that
why are
as you
you
look up, the reason that they didn't take the measurements upwards is because that the water vapor in the air decreased.
No, I didn't say that.
Hang on, please. Let me just clarify. It decreased in intensity as you went through the layers, as you go upwards, because the atmosphere thins out. But you're also saying that the more accurate measurements were taken to the thickest layer of water atmosphere horizontally?
No, I didn't say anything about water. Somebody asked me if humidity causes the air to be less dense or more dense, and I said less. And then
more humidity. Hold on, more humidity, the less dense the air is. That's what.
Yes.
That's what
When
you're
you
saying.
put
water in the air.
More water in the air. Okay, there's higher humidity. The air is thinner. It's less dense.
That's why light refracts upward.
That's
why things appear. That's why the sun sets, people.
Yelling at Jeremy. So one reason we know this, it kind of sounds counterintuitive, because typically when we think about air, we think it's muggy outside, and it's like, oh, the air is real thick. Well, actually, interestingly enough, hot air is less dense, and more humid air is less dense. So
like
the worst
welcome
time
to flat Earth.
Wait a minute.
Flying
You're roboting, RC. You're
hot,
roboting real
humid
bad.
air because the air is the least.
Welcome to
You're
really simple.
roboting. Hey, hold on. Just
Hold
let
on,
me
y'all.
follow up
Welcome
on
to
that real
Flat Earth.
quick. Let me follow
This
up
is
on
how
that
the
real
sun
quick.
sets.
So, Brian,
Brandon.
for fuck's sake. So let me ask you this. Let's say, when does that stop? I've got 0% humidity. And I'm just cranking up the humidity, right? 20,
I mean,
30,
there's
40,
never
50,
really
60, 70, 80, 90,
never
100. Keep going, right? But that's it, 100.
You can't go past 100.
I
get
can't
you
go
too
past
easy now,
100.
Brandon.
So more water, less air within a certain amount of space is less
No, it's-
dense than just air.
Yes.
Would you like to
Yes,
know
because
why?
the sun sets. We're
Would
gonna be
you
on a flat Earth.
would you
That's
like
gonna
to
be a little
know
later
why?
too.
Yeah. Let's
Would you
Hey,
would you like to
hey,
know
Brand,
I've
why?
read this
hold on. Hey,
before, but
Brenda,
it is
Brenda,
it is
Brenda, just give me
counterintuitive. So
a second.
But he
Hey,
has to say that,
Brandon, it is.
because he's
Can you
funky.
hold up a second?
Ah, damn.
Hey, Brandon.
hold on.
Brandon, I do know that sounds counterintuitive. But it is a fact that when you have more humid air, it is indeed less dense. This is like a Googleable and like verifiable fact.
Right.
Didn't say I'd never
Would you-
fucking heard it before. All of us have heard it
I know,
before.
I'm not-
All I did
I'm
was
not-
ask
I'm
a
not
question.
criticizing you, Brandon.
Do you find that
I'm actually
counterintuitive or not?
I do find it
Explain why.
counterintuitive
Exactly.
Yes.
That's all my
Explain
point.
I do not. I do not.
because typically.
Brenda, give me a second.
because
Meisty, let me ask you a
look,
question.
Can I actually respond to what Brandon said?
Yeah,
Because
but you're shitting on the
Brandon
show,
asked a
bro.
really
You're not
good
letting nobody
question.
respond to you, brother. Let me ask you a
Brian,
question,
why are you
Meisty.
yelling?
This is
Brenda.
directly
Guys,
to you, buddy. This is directly to
So Brian,
directly to
I'm
Meisty. Okay,
validating.
Meisty.
Oh my
You
God.
say that the water in the air
Wasn't
makes it less
Meisty
dense. Okay?
talking? What
You also
about
said
Children,
that,
children have to talk. Children have to talk, and they have no manners.
Brenda, shut
Children,
up, man.
children
I'm trying to
have
ask
no
Meisty a
manners.
question, man. Let me ask Meisty a
It's
question,
not your
goddammit.
turn,
It's an
child.
easy question.
It's not
hey,
your
listen,
turn, little
guys,
boy.
Brian, Pete, everybody. I'm gonna start muting people who just continuously talk all over each other and have to jump in every conversation. It's the only way this is gonna work.
That's the forward you in
So
there.
I'm gonna shit on the show on purpose, Brandon. I know you see that. I hope you see that.
No.
What the fuck you talking about?
The best way to look at the density issue with water
Meisty, man. Okay.
is to understand that the higher motion of molecule will equal less density. The slower the molecule will equal more density. So if you want to look at something counterintuitive, it's just how you're looking at it. If there's more energy exchange in this particular case, it will expand the gases, if you will, making them less dense.
You're an idiot.
So Brandon, the reason that I say
I'm an idiot because I'm telling you exactly how it works. Is that what you're saying?
Hey,
Yeah,
Brandon,
you'll wait
the
to the
reason-
right
the
answer
reason
and
that-
then you'll hurry.
Can I actually respond or no? Is everybody just gonna talk? So Brandon,
The
reason
gloves are
that-
fighting for fucking airspace. Not even letting us
Brian.
talk.
So Brandon, the reason that it does seem counterintuitive is because we typically think of like humid air as we call it muggy, or oh, the air's really thick, right? But the reality is like when air is hot and it's humid, it's actually much less dense. It's just the interaction with our skin makes it really uncomfortable for us, right? And so, but the point is that hot humid air is actually much less dense than
Explain
cold
why.
non-humid.
Tell them why.
Because the molecule is in a higher velocity of motion, expanding the volume of the gas, becoming less dense.
No.
Yes, that's exactly what it is.
It's because the water
It's a-
vapor molecule has a different bond. They bond together with the van der Waals or whatever. It's not the same kind of bond as a covalent bond. And a covalent bond, N2, which the atmosphere is made out of, is more dense than the water.
I mean, the reality is that water vapor, right, in and of itself, like when you put water into a gas, is simply less dense than the composition of normal air below 50,000 feet. That's
Right,
the reason.
So we would expect to find, where would we find the most water vapor? Lower to the ground or higher up?
I mean, typically it's between here and 40,000 feet.
So the lower you get, the more water vapor you would expect
Well,
to see, or
it
how
kind
does
of
that work?
depends on the frontal activity at the time.
It depends on the what. Sorry, there was a noise.
Depends on the front activity at the time. If you have an occluded front, for example, you're going to actually have more water vapor higher up. If you have just a cold front, it's going to be slightly overtaking there. It just depends on the front activity is how much humidity is going to be in the air.
So in cold temperatures, we would expect to see more less dense layer of atmosphere towards the bottom.
More, and colder air means more dense air.
And hotter air. So in hotter
less
climates,
dense
hotter climates, we would expect to see
It's
more
less
humidity at the ground.
And colder
in
air,
hotter climates, would we expect to see more humidity at the ground or higher?
It depends on the type of climate that's around there, right? And it depends on what the air masses are around it.
So there's a lot of times where it's. So there's a lot of times where the less. Go ahead.
Yeah. So for example, I lived in Utah for a long time, right? Typically, the humidity in the air was like very, very little compared to in
Brian, your mic is giving feedback. Hold on, RC. Brian, your mic is giving feedback. It's open or something. Thank you.
Go ahead.
Go ahead.
Yeah, when I lived in Utah, it was much less humid air, right? Mostly because of the interaction with the mountains and the front activity that was coming through there. Where I live here in Indiana, we don't have mountains, and so most of the humidity that comes along, or the water vapor that comes along with the fronts, or is already here, right? Typically gives a lot more rain and a lot more humid atmosphere. It just all depends on what both the topography and the air masses that are going through there are.
Can I get a quick turn now? A quick turn. Just wanted to ask Meisty. So the colder the air, the more dense it is, and the drier the air, the more dense it is. Correct?
Yes, correct.
So that would mean that light would refract toward the more dense medium, the colder air up above, and the less humid air up above.
Well, it depends on what the other.
Welcome to sunset on a flat Earth, Meisty.
All right. Do you want me to respond to you? So it depends on if it's going to refract toward. The question is, well, what is the other medium that you're talking about? So, for example, I'll give you a good example. If you have like a very cool, like Lake Michigan, and then you get very warm air because of a warm front that comes through, that in the morning goes over that very cool air, you're going to get like a more downward refraction.
Let me read
plain as day using their science. People can use their science and explain a sunset on a flat Earth perfectly. That's why I made my model, because they say it every time we argue. They say it's less dense down below because of the water and because of the hotter air. So so the only medium change is the air pressure, which is very little to nothing. But what you do have is where the humidity totally runs out, right above cloud level. So over long distances, that would cause sunlight to refract upward, making the sun appear to set down close to the horizon.
So cold air holds less humidity and warm air, you're saying, right?
Well, the humidity and temperature aren't exactly corollary, right? Those aren't like one-to-one things. You can have very humid, cold air. It's harder to typically here in the United States because of the air masses that we have in the topography, right? But it's not impossible to have humid, cold air. In fact, that's how you get things like freezing rain or freezing frost.
All right. Well, let me read something off. Within the troposphere, higher elevations usually have lower temperatures, meaning the air can hold less water. That's from
the reason that higher elevations hold less water is because the air itself is less dense, and it actually can't. It's really hard to you can sublimate things really easily, but it's really hard to evaporate. Especially things like water.
You guys are essentially discussing water vapor and the effects.
Well, Brian was just talking about the temperatures and the humidity and stuff like that. But as RC Meister just said, as the pressure changes, the amount of air per given volume is going to change as well. So the density of air is actually the overall density of the air is changing as you raise it up.
And in fact, in aviation, we call this the temperature lapse rate. The temperature lapse rate in any given context is actually almost the exact same because the temperature changes because of the density difference, not because of anything else, right?
Yeah, but the lapse rate does not take perspective into account. So you're going by orthographic view of the lapse rate, but the way we look, looking straight out, we're looking at like 2-3 miles in the air over a distance of about 15-20 miles, much less a few thousand miles.
Brandon,
Even your lapse rate backfires on you.
Brian, a lapse rate is about a temperature change. It's not about because of a density difference. That's not talking about a perspective thing. Okay, it has nothing to
right. But you still have to consider perspective because you're taking this lapse rate of the temperature changing. But okay, if I'm looking straight out, Meisty, and in front of me, 50 miles ahead is 5 miles in the air, are you considering a lapse rate from my perspective view to my eye, or from my orthographic view to my eye?
Brian, I don't even understand your question.
Wait a minute. I think there's a confusion. Brian is talking about something different than you're talking about. You're talking about lapse rate as in relation to temperature in the atmosphere. This has nothing to do with light, correct?
Yeah. I think Brian's trying to get this. Yeah, he's got it mixed up.
No, he just the lapse rate is also used to describe a certain way light moves through the atmosphere, right?
Well, no, lapse rate isn't really talked about when it comes to like how
it is actually. Yeah, it is actually. That is talking.
Well, Brandon, did you read my reply? There's another guy named Frank Pierce that did this apparatus again in a different location, and nothing occurred. So I just wanted to point that out. I would agree with RC on the pressure, but since this guy's apparatus did not have a interference pattern, how can you explain that?
Yeah, so I just want to jump in. Results in different locations then, but it might have been a different apparatus, different setup. This isn't exactly an experiment, but yeah.
Yeah, just to back you up real quick, Brandon, the lapse rate is intrinsically tied to refraction when talking about mirages and other refractive phenomenon. Absolutely.
Thank you.
Yeah, that's typically on the the horizontal axis. We're talking just about the lapse rate of temperature on the vertical axis is what I was getting at.
Well, describe what this lapse rate is that you're talking about, Meisty.
Yeah, so for about every 1,000 feet that you go up, the lapse rate that I was talking about, that we talk about, for every 1,000 feet you go up, you lose about 1.5 degrees Celsius of temperature due to the density differentiation of the air. That's what I was talking about.
And you know a lot about this, I assume, because you're a pilot. This has a huge impact on flying through the air, right?
Yeah, huge impact on flying and huge impact on like how we look at things like weather phenomena, or how we look at like density of the air and calculating like how we work in general.
Oh, okay, that's interesting because I thought Coriolis caused the weather, but I must have got some bad information yesterday. Anyway.
That was a funny slide there, Brandon.
Well, RC is a pilot. I don't usually get a chance to talk to him. Do you know about the 2 FMS database compasses? RC? Well, he's a pilot, so I wanted to ask him that question.
The 2 what, Don? Say it one more time.
Did somebody
The
claim
FMS
that Coriolis
database.
causes the weather?
It's updated every 28 days to account for the world's terrain and buildings.
Sorry,
you know
what
about
was
that?
the question?
What is the FMS database? The code.
FMS database. The FMS is just a flight management system. It's a little computer that we use to plug in things, coordinates or airports that you want to go to, or waypoints in the air. It's just connected to all of our radio navigation and into our GPS navigation. What do you want to know about it? It's updated actually more often than that. It's usually updated like every 7 days now for commercial airplanes, 28 days for like more civilian subscription. It just depends on your Garmin or Avidyne subscriptions that you have.
Do you guys get the actual code, or do you receive, like, because when I heard it is they take a flat Earth map into the code, and then you guys get the ball Earth route.
Yeah, that's not true. We definitely
have you looked at the code?
We definitely get coordinate systems that are based on a globe and that are great.
Yes,
circle.
right. Yes, you get the program. You get the app. It's like you get you receive that information. Do you look at the original code?
Yes, we have to look at the original code when we download it each time because it actually fits on a little what do you call it? Kind of like what are those camera disc things called? The SD something, the ST. Is that what you call them? I always forget.
SD cards.
Yeah, the SD cards. They actually get downloaded on like 2 or 3 SD cards depending on your FMS.
Becky,
Now,
did
Mike,
Becky drop off?
load up in the fucking
You
airplane.
can look at every single update that is happening. Yes, you can see
You ain't writing code up in the fucking airplane, buddy. Quit lying.
Yeah, you don't
Hey,
have the
Becky,
code, RC.
Yes.
Yeah, I mean,
no.
yes,
This
yes,
is what happened. This is why I said that thing about Coriolis. The person didn't say it was Coriolis. I was asking for an explanation of why the atmosphere moves in lockstep with the Earth, and they said that the wind is caused by lack of drag with the atmosphere from its rotation, which I thought was pretty interesting.
Who said that?
Somebody in Discord.
Yeah, so wind is simply called, there's one thing that drives weather on this earth as a principal means of like the power source, and that's the sun. It's heating, right? So all wind is caused because of a pressure differential. All pressure differential at the surface and in the atmosphere is caused by heating or not heating of the surface, and that has everything to do with surface and sun stuff. Now, the question is,
wouldn't it be interesting, man?
Hold up. Well, the question is, why does wind move in the patterns that it does once that heating happens? Now, that's where Coriolis comes in, but it's a secondary force that exists to the heating.
Mike, have you ever considered the lapse rate, like in perspective? Like, pretend you're standing on a cliff and you're looking out into the distance, okay, or even on the ground or in a plane. And have you ever considered the lapse rate and how it would appear if you mapped it perspective-wise instead of orthographic? I know y'all like to think 1-2-dimensionally. Okay, I'm good with it working like with the density and the drag of the airplane and all that. I'm good with that. But as far as the way we see perspective, my point is if anybody out there, if y'all can imagine a lapse rate being a temperature differential as you know, with altitude, picture that in perspective view. It would flip itself, even if light was curving downward the way they claim it to be. It would still, because of perspective, the perspective would take over and make it appear to bend upward, still making the sun set over a flat Earth. Any way they look at it, flat Earth is fine. I know I'm bending the topic a little bit, but that's what the light boils down to, in my opinion.
Anyway, back to what you said, Brandon. So it's not that Coriolis has no effect on the wind. It's just that the wind is primarily caused by heat differentiation that's driven by sun.
Of
You
course,
guys are
if we dug
crazy.
into that,
You
we would
actually
find out
think
that
that's
you
it.
have zero evidence that Coriolis causes anything to do with the wind or weather. But that's
Yeah,
okay.
can
Go
I
ahead,
see a
Becky.
citation for
It's
that from a
easily proved.
meteorologist or anything? Is there a citation for you claiming that garbage?
Yes, there is plenty of it.
Isn't there a hurricane over Louisiana right now that's rotating?
Yeah, and you watched that hurricane, right? Have
did you
seen how
watch it?
dumps
Guys,
it? You want to claim that
So
Coriolis?
How did we get
anticyclones
pictures?
don't matter, right?
Yeah, I mean,
How
I mean,
did
the
we get
easiest way
pictures
to,
of the
I mean,
hurricane?
the easiest way to see Coriolis inside of hurricane is watch a cyclone in the southern hemisphere versus watch a hurricane in the northern hemisphere. You see the differentiating rotations. That
Hey,
exist.
RC, remember about 2 minutes ago when you just told us that the main driver of weather on the Earth is the sun?
Yep, and then I said that
And then the
Coriolis
sun's
is a
path
secondary effect.
is centered around the equator, right? So
Yeah,
we expect to see some mirrored impacts from the sun moving
No, no.
across the surface of the
What-
Earth over the area of the equator on either side of the sun.
Yeah,
Not
that
at the
really,
equator.
that really wouldn't cause any differentiation in
Really?
the path of the
It
wind.
wouldn't cause
No.
a pattern? The sun moving across the Earth doesn't cause any patterns in the weather?
No.
Really?
Wait.
Well, I don't know. It's the main driver of weather on Earth
on.
and the weather patterns, but it's not going to cause any patterns. It's
The
interesting.
thing
Right,
is, the
Brandon,
moon
wait,
passes the sun.
stop, just wait, stop, wait. Make sure, Brandon, make sure they understand why you're suggesting this, right? Because I understand the implications, but I don't know that they do, right? So can anybody like either RC or Howard
I'm not sure that you
Instead
guys
of
understand.
hold on, Kosho. Instead of RC and Howard saying no, you're wrong. What is the implication of what Brandon is suggesting? Can we get your statement on that so we know you understand what he's saying?
Yeah, he's saying
the sun's movement causes the swirls.
I'm not asking you, Kosho.
He's saying the sun passes across the equator, causing the hurricanes to swirl.
Yeah,
Okay,
that's not what happens.
Okay, great. I didn't ask for a negation. Okay, so why? Okay, so do you understand again, though? Even though you're right that it causes the pattern, why does it cause one in one direction and one in the other?
Because of Coriolis.
Okay, Brender, I'm not talking to you. I'm talking to Howard right now. Shut up.
But if you try this like in like water,
No, don't try. Don't try to explain it away right now.
It will cause the circulations will be opposite of what we observe with
okay.
What about what we observe on Jupiter? Oh, my bad. Go ahead, Travis.
Yeah, I'm just okay. Again. The simplicity of what we understand on a small scale in our local proximity when we see different eddies as a result of interference, it is simply reasonable. You don't have to agree with it, but it is reasonable that this object up in the sky is passing through a medium that is fluid, and because we can see one thing on Earth, it would be reasonable to say, that might be what's happening up in the air.
No, it's not possible.
I know you say that,
Well,
but that's
we see
not
on
possible.
Jupiter.
It's not possible.
On Jupiter,
I know you say that it's not possible. I know, and no one gives a shit what you say.
Because it's a giant thermonuclear bomb.
Yeah, I would
What is
think
a giant thermonuclear bomb, Brenda?
I would say if the sun was
Shut
causing
the fuck
that,
up, Brenda. Go ahead, Howard.
you would. I would think if the sun was causing that you would see that circumferentially around the Earth, around the equator on a daily basis, because the sun goes through every day.
And like he said it right the first time, though, they're rotating the opposite directions. So if they're causing
Then
these
we would see it
currents,
every
if they're
day
causing
on
these,
Mars, too.
if they're causing
If the
these
sun is
swirls,
the primary cause.
if they're causing these swirls because of the heat, they'd be rotating the opposite direction. Those swirls would be.
No,
It
they
doesn't make
wouldn't.
sense that they'd be causing-
Why do you
Yeah,
say
of course
that? Why are you making these declarations that it would do this if that was the cause? Why are you
That's what
making
he
that?
just gave it a mechanism. He just said it's just like if it were on a small scale when you are moving something, you're heating something, you're moving across water or cave
What are we
batter.
talking about? A
Swirls-
miniature
it
sun
swirls
over
in the other
water?
direction.
Are we talking about moving a miniature sun over water? Is that what we're talking about?
I mean, don't we see on Jupiter
do
don't we see on Jupiter that it's working backwards as you guys claim that it works on Earth, and then you say, oh no, it's because of a different cause now it's making it.
No. The storm on Jupiter is a high pressure system, which would operate in reverse of a low pressure system, which we see in hurricane.
So it's based on pressure, not the spinning of the body.
If the hurricane was a high pressure storm system with high pressure in the middle pushing clouds outward, the hurricanes would rotate in an opposite direction.
Okay, so it's based on the pressure system that the hurricane's in.
Oh,
and
yeah.
not the Coriolis effect. We know.
In conjunction,
we already know that. Thank you, Howard.
Yeah, the correlation effect is real, and it's what causes spinning hurricanes to go in different directions in northern and southern hemisphere.
Yeah, a nice declaration.
I didn't hear anything you said.
You misspoke, Brenda. You said the correlation.
That's funny. Anyways, on Jupiter, they got it working backwards, and now it's okay. Whatever. You misspoke. Anyways. On Jupiter, you got it working backwards, and you say it would happen on Earth, and then you say it's because of a different pressure system. So, I mean, is the pressure system the cause of the direction of spin, or is it the Coriolis?
Well, the pressure system would determine the flow, whether it would flow inward towards the center, low pressure, or outward from the center in a high pressure. The rotation is the Coriolis.
I can't believe how many weather experts we have on the
So
panel
it's
today.
really
It's
simple,
amazing.
though.
Hey,
So
do you guys have any experimental evidence that shows that Coriolis causes any type of weather phenomenon on Earth?
Yes.
Oh, I'd be interested in
No, you
seeing
don't.
that because it's never been produced before.
It has.
No, it
I'll show
hasn't.
it
Can I
again.
ask a question real
I've
quick by
produced it
chance?
before. I'll
No, you
produce it
haven't.
again right now. Yeah,
Sure.
I have. I have, Brennan. I absolutely
haven't.
have.
Oh, this is
I'll do it again right
Hurricane
now.
Hotel.
Can I ask a question, Brandon, real quick? Because we're talking about hurricanes and stuff. We're talking about cyclones and then anti-cyclones. Can you tell me, because they spin in the opposite direction in the northern hemisphere. So can you explain that then, and why Coriolis is having effect on that, please?
Just like
I just-
Jupiter.
Yeah, high pressure and low pressure systems.
When it doesn't fit the
That's why they
model, it's
spin it.
caused by high pressure and low pressure. When it fits the model, it's Earth spin. Just like when there's no hurricanes
Right.
over South America and Africa, Earth curve doesn't impact the atmosphere the same way there.
no, it's the
Yeah.
same
Amazing.
thing. It's the same phenomenon. It's because as the air from the equator rushes to the north, it gets ahead of the rotation of the Earth, therefore
my God.
causing a counterclockwise spin.
So
Right?
if you guys
And
want
then
to, you
going
guys
the
want
other
to bring up something,
direction, going
Sorry,
the
I'm
other
literally
direction,
lifting
it
this
causes
up,
a
and that's
counterclockwise
rubbish.
spin.
Let
Brenda?
her finish. Just let her finish. please.
can I bring something
It's
to
really
attention
simple.
to Brenda maybe? Brenda, do you know about the consistent wave patterns that are all over Earth? Like wave patterns that are at a certain height consistently one after another?
Oh, so we're switching the
Are you-
topic from hurricanes
No,
now?
no, it's about Coriolis. It's related to Coriolis. It's actually related to the whole debate and conversation. Are you familiar with the Euphorus problem? I don't know if I'm saying that correctly.
No idea.
Okay, so there's this tide problem in a place called Euripus. I'm totally saying it incorrectly. Euripus. Anyway, they have lots of theories and trying to explain it, but they can't because it doesn't correlate with the theory that the Earth's a ball and the moon and tides are associated and so forth and da-da-da-da, right? It acts independently of all these theories and problems. Anyway, relating to that particular point, there's also the anticyclone issue that's going on right now in Greece.
Which is
That's
what we're
basically
trying to bring
causing,
out and talk about.
yeah, it's causing really weird tidal patterns that everybody's confused. What's going on? The weather's extremely hot. I think they actually call it Lucifer, this anticyclone that's going on in Greece right now. Yeah. So here, I'll see if I can get it for you. I just read it a while back, and I'm trying to. Give me a second.
Oh, this is interesting.
Trying to remember it.
Cyclone is causing earthquake fears. Huh.
Yeah, but go past that. Go to the Greece
Oh,
and
here I got
the
weather. Oh, come on. Just. Oh. Make me choose. Weather warning issued as rare cyclone heads to Greece. A cyclone dubbed Lanos. Somebody figure out who Lanos is. Will hit western parts of Greece first on Thursday afternoon, creating potentially dangerous conditions. And this is supposed to be an anticyclone?
That's the issue. It's an anticyclone, and it's fucking with the tides in Greece. It's been going on for a few years. The scientists have no clue what's going on. Like the tides are irregular, right? They're not matching up. Plus, there's that place. I can't even pronounce it, but Euripus. Euripus. That particular place has these consistent wave patterns, and I guess, according to the theory of gravitational attraction to the moon and tides, this phenomenon acts independently of that and does whatever the fuck it wants. It appears as if there's no laws or reason to why these waves continuously to do what they do at that certain height consistently one after another, right? So NASA writes about it on their website. You can go read about it, but it totally destroys this notion of a spinning, rotating Earth because it doesn't.
How does it do that?
Spell it again.
Because it doesn't fit any of the laws.
Wait,
that
can you
man
spell
has
that
come up
again?
with.
But how does that refute the globe?
Shut up, Brendan. Shut up. Can you spell that again, Data, please?
EURIPUS.
U.S.
PUS. Peter, Uranus, Sam.
I did find an article, more weather porn. An anticyclone, ironically named Lucifer, is slowly moving north over the Mediterranean country of Italy, Greece, and Spain, causing Sicily to record Europe's hottest temperature ever. 120 degrees Fahrenheit. Holy shit. That's hot. I don't know how many of you have been in 120 degrees, but that is fucking hot.
Wait till you get to Euripus and read about how it doesn't obey any of the laws man has written for the top moon tides and rotation and Coriolis.
Well, that's interesting. Here's another example of something that goes against your model.
Oh, this is a heat dome.
Oh, it's a heat dome.
Oh, is that it? That's all it is. Oh, okay.
Yeah, let's hear this ad hoc explanation. Go ahead, Brenda.
No, that's just what one of the results in the Google return says, that it's a heat dome.
Oh, well, that's what I always do too. I Google something, and then the first thing that matches my bias, I take that up and say, oh, that explains it. It's a good idea.
So what Brenda does, you've been watching her?
Yeah.
My Google searches are highly biased. I search for the exact thing I'm looking for.
So I was able to find that title thing. You're specifically talking about the Aegean Sea. The Aegean Sea, like the Mediterranean Sea, has weird tidal patterns. These are driven more by local wind currents than by other things because of the body of water and its ability to get to others. It is completely explained.
Here's something you're gonna have to realize. There's places on this earth that have the consistent wave height and consistent flow one after another, and there's no explanation. You can say it's wind all you want, but that doesn't explain the consistent height pattern one after another if there's different wind changes. Right?
Right, but what you're talking about is the tides in the Aegean Sea, and those are
I'm talking about Euripus. I'm talking about the Euripus problem. They call it a problem, okay? Because the issue with the Syzygy and the moon, it doesn't, according to their gravitational moon attraction stuff, these waves do this pattern that doesn't match the whatever they've calculated, I suppose, what gravity is supposed to do with the wave, with the tidal wave, right?
There are spots with no tides at all.
It's like
that are anomalies.
It's like a week's worth. It's like a week's worth of waves that don't line up with the laws, something like that. It's like 5 or 6 days or something.
Yeah. This is well known. This is one of the features of the Aegean Sea. This has been explained for thousands of years.
Sure.
There's no confusion.
There's no law. No, listen. It's called a problem for a reason. It's because it doesn't
Except
obey
it's not
any of
called
the
a problem.
laws.
It's called
the
phenomenon.
It's literally, well, you can research the problem too. Type in Icarus problem and you'll get papers on it. So try it.
Yeah. They've known it for a really long time though. Sailboats have been using this.
I'm just bringing it.
Years.
I'm just bringing it to your attention. I'm bringing it to Brandon's attention. I'm bringing it to other people's attention because there's a purpose. Thanks.
Right. Taylor figured this out a long time ago.
And he didn't say.
Well, the source.
And he didn't say no one knew about it. He didn't say that. So that your statement is a complete non sequitur. Everybody knew about it. We've already known it. We've always known about it. That's not what he said.
Well, even if there are anomalous events, they don't refute a general theory.
Of course. Yeah, of course.
They don't.
Yeah,
they don't.
Of course. Yeah.
They don't obey the laws. That's a quote from your own science, guy.
Well, you'd have to show that.
What?
And
here's a full
explanation. It's in the papers. Go read it. Go read
There's
it.
a
It's in the
full
paper.
explanation in the encyclopedia if you want to look it up. I mean, you can say it's a problem. Here's the solution.
Cool.
Would you post that? Would you
It
post that
doesn't
link,
obey the
please?
laws, right? So why would they say
shoot,
that?
I posted in the wrong chat. Sorry.
Hold on. Is that the paper by Eugenides from 1929? Is that the paper you're referring to?
I have no idea. I don't remember.
Let me read a
'Cause
couple
that's the,
things real quick here.
that's
A couple messages from Lael. Lael, $5. Hey, Brandon, tell Pete Lael says hi. He's on deafen. Sorry. Lael, apologize for that.
Been
And then
studied
Lael,
since the time
$10.
of Aristotle.
Lael, $10. The fact is that Morley, 10 years before the interferometer experiment, has measured the most accurate at that time for the speed of light, and that is what Morley used in future experiments. All right. Thank you very much, Lael. Appreciate that. Go ahead. No?
So are we clear? I'm not sure that we ever got clear on how weather is caused and how hurricanes spin in opposite
No,
directions.
I think we're clear, actually. I think we're good.
I think you're pretty dang clear.
Are we? You are?
Yeah. Yeah, pretty
Yeah.
clear. You guys talk about a bunch of crap, like how you know how things exist, there's always anomalies happening. But at the end of the day, honey, you're seeing always anomalies in the weather, just like now by Cali and stuff too, doing a 160-degree turn. But in the same time, you talk about anticyclones and all this other stuff, but in reality, you still cannot prove this fucking Coriolis that you're talking about. Where's the
So
citation?
you don't-
Show me
so you
proof.
don't
Wait,
understand it.
Wait, I'm not done. You can show me a piece of paper that tells me it exists, but you can't prove that shit. You know it.
Yeah, the way you would
simply
prove Coriolis would be to get in the both of the reference frames associated with Coriolis, and you would be able to see one going in a straight
So-
line and the other one curving. So
you can prove the principle of Coriolis for yourself just on a
we already know
rotating table.
Coriolis is a thing.
A
We already know
rotating table.
Coriolis is a real thing.
Therefore, since it's a thing, and if you have a rotating object and another
Oh,
thing in an
Brenda,
inertial
shut up.
flame,
Shut up.
then it must be, right?
Brenda.
I'd like to
Please
bring it
don't
back to the
take
gas
us back.
pressure.
We're not talking about whether Coriolis is an actual fucking concept. We're talking about whether
Yeah.
there is Earth-based Coriolis, and you know that damn well.
If the conditions necessary for Coriolis exist, then it must exist
Anyway,
because
sorry,
it is
Jeremy, I
a
cut you off.
principle of physics.
No, you're all good. Let me just bring it back to the gas pressure real quick.
Go for it.
Yes, pressure.
What happened?
Ah, thought it was me.
my
No,
bad.
we're still waiting on Jeremy. You there, Jeremy?
No, my bad. My bad. Yeah, they're saying the bottom layer of the air is more dense. However, they're saying humid air is less dense because there's more humidity in it and it's down low. They also say cold air is denser than warm air. What is making them think that the more denser part is on the bottom? The pressure? Because there's more
Yes,
pressure?
Absolutely.
That doesn't dictate whether there's more molecules in it. That could be temperature based.
Vapor pressure, think of vapor pressure. So any exchange of energy is going to be closer to the surface. Right?
I could have more I could have
if you have higher
get
vapor
more pressure in a balloon. I could get more pressure in a hot balloon, and when the balloon gets cold, you can visibly see it.
And
Well,
it's
it
well known that
expands volume.
temperature is the main
It's
driver, right?
No, it's not.
Yeah, it is actually. So temperature, let's say if there was a much higher temperature at 1 foot than 10 foot, it would be a lot less dense at 1 foot than at 10 feet, right?
Can we just talk about what that means? That means
Correct,
that
Kosho?
the molecules expanding
No.
and contracting.
Really?
For instance, if you have a column of air like the one in your room from floor to the ceiling, it's consistently raising in pressure as you get to the floor. The temperature does not follow this way at all.
Does temperature impact pressure?
It does, yeah.
Okay, so if I have a temperature differential lower versus higher, there's going to be some point where that's going to cause a bigger delta than just the pressure of the air, the density of the air alone, right? Just its altitude.
It's possible to have.
Not only is it
temperature
possible,
differences. It's
it
possible to have
happens all
temperature
the time.
differences. It's possible to have temperature differences that are so different from one another, that are so close that outdoes the pressure difference. However, the pressure is still going to. I mean, the pressure changes with that anyway. So the pressure is going to be the deciding factor.
What?
Isn't it driven by temperature, the change? It has to be driven ultimately by temperature to have the change. You can't have the change of the temperature, right?
Kosho, are you trying to claim this as being the directional, why there's the directions? Is that what you're using this for?
I'm not sure he wants to continue. I don't think that made much sense. The last thing he
Somebody's
said.
at the door. I'm sorry. Yeah, I don't know the last thing you said.
Is this your
argument? The last thing you said didn't make any sense.
You're right.
But go ahead.
The temperatures influence the pressure, right? But the pressure is going to ultimately determine the density. So you're right that there's a relation between the temperature and the density, but the pressure is going to change with that.
Oh shit.
Yeah, but it's the pressure that is consistently changing as you raise and lower altitude.
Whereas the temperature can overtake that. Temperature will make a bigger differential than the fucking height.
And yeah, not always. It depends on how different they are.
Not always, but it can very easily, correct?
It's possible that it can, but it's not.
It happens all the time. Not only is it possible, it happens all the fucking time.
You mean like mirage? Because they're, I think, the most common example of that happening, right?
Yeah, I guess that would be one example.
So you're saying that you're saying that the pressure differential is purely temperature.
No, I'm not.
Okay.
I never said that.
Well, usually when we have hotter air below colder air, the hot air rises, right?
Yeah, like a hot air balloon. That's what that is all based on.
Yeah, because it weighs less.
That's called
That's what I'm saying. Those are extreme. Those are two extreme differences.
But doesn't
if
it
you have
increase
these, if
in
you have a big
volume,
enough
though?
difference close to each other, then
Doesn't the air expand, increase in volume, and when it increases in volume, it creates a differential pressure? The molecules are
warm fronts and cold
moving.
fronts.
Molecules are moving faster and farther apart. That's your
So the
explanation,
hot air
right?
balloon. So we fill this balloon up with hot air, and it's less dense, so it goes up, right? But you're telling me the hot air, yeah, right. That's how it works.
Yeah.
It increases in volume and creates a differential pressure, and that's what gives it its force. That's what I think happens. The molecule expands and has a greater distance, and so it increases in volume.
No,
Yeah, but they're saying the air down here is more dense, but we're making hot air and it's going up. So how would the hot air be more dense on the bottom? It wants to go up.
Yeah.
Yeah, when you do something like a hot
Am I
air
making sense, or
when
I
you
am
have-
mad high right now.
When you have these big enough differences, then you're gonna obviously you're gonna see that reaction, right? But there's a consistent rate of the pressure changing as you go from the floor to the ceiling or from the ground to the sky, and with that change, there's a density change as well. The only difference is, like I said, the temperatures can, whether it's caused by the sun or hot air balloon or whatever, you could have massive differences which are going to create this effect. But the consistent effect, the persistent effect, is the one where it's just going from floor to ceiling, or ground to sky.
Would you say, Kosho, that at a higher altitude of 60,000 feet, there'll be temperatures around -50, and that would be the lack of energy exchange due to the surface of the Earth? Would you agree that there's more energy exchange to the surface of the Earth, and through that energy exchange produces vapor pressure? And that vapor pressure increases the volume of the gas, which creates a differential pressure against the condensed gas. They're creating a front, if you will.
I say it's much simpler than that. That's just there's less air up there, and so that's why there's less energy exchange. there's more air down here, and even though it's colder up there, on average molecule, there's less air.
The reason why it's more interactive below is because there is more matter to interact with than above.
Yeah, that's right.
Right? Yeah. So the pressure force, or the vapor pressure, is created at the surface of the Earth. And that exchange of energy obviously has like a inverse square law, let's say, from the surface to 50,000 feet where it is minus 50.
Yeah, no, I don't agree with any of that stuff that you said.
If you have something interacting with molecules, which is the sun is the driving factor that's heating up the surface of the Earth, and there's an energy exchange with gases, with water, essentially evaporating.
I understand what you said.
Producing a cycle effect, right? Independent of anything else, this is what's going on.
All right. So what you said, the vapor is being created down below. This is not the case. The reason this was my whole point. The reason why it's more dense and there's more air down below per volume is because there's more pressure down below, and the pressure isn't there because the gases are created there.
Yeah. So vapor pressure itself, the act of vapor pressure, creates a measurable force, right? With the exchange or front, if you will, of high and low pressure, you have not columns, but what do you call it? Anisotropic movement of gases. They're homogeneous in a sense, but it's anisotropic, right? Isn't that correct? It will move due to the dynamic function of the differential pressure and the exchange of energy.
Are you looking for a response?
I'm just saying, did you?
They like to say there's more of a change in there's more refraction when there's a change in medium. Okay, but they want to say that the change in air pressure being overrides the change from humidity, an atmosphere with humidity, to an atmosphere with non-humidity. Okay, over distance, that would way overtake. They say when it's colder, it's denser. It's colder up higher. They say when there's less humidity, it's denser. Then it's denser up higher. Everything about it says that over distance, over long periods, maybe not short periods, but over long distances, the sunlight would refract upward, making it the sunset. I mean, they don't like it, but they pretty much state it with everything they say.
Until the end.
That doesn't happen. Yeah.
No, you were pretty much there until the end. Then you're like veered off.
Well, you guys were desperate to cut that off, weren't you?
No, it's funny. He got there right. He was going. And he's pretty much on the level. Then suddenly they veered.
Okay, what's the correct thing?
Let me clarify then. Allow me to clarify. Okay, y'all say that light refracts to the denser medium. Okay, y'all also say humidity is less dense. Water vapor, the shit we find at the ground, is less dense than air. Okay, so what do we have a bunch of at ground level and water level? Humidity, meaning the light would refract up according to y'all's definition. Okay, same thing with temperature.
No, it
gets colder, higher. So you're saying that the change in pressure, not density, pressure, air pressure, is overriding the change in medium. I think that the refraction would dictate the change in medium, the humidity to non-humidity, the atmosphere with humidity compared to the atmosphere of non-humidity at about 50,000 feet, which is about how high the sun appears after about 4,000 or 5,000 miles. The sun would have to set over a flat Earth. It would have to, according to y'all's definition.
No, it could never. But the air closest to the ocean is denser than the air, say, a kilometer above it.
So the more pressure, the more density. That's what they're saying. The more pressure, the more density. Forget all the humidity. Forget the change in medium.
That's what's happening at the surface. That's what's happening at the surface. There's going to be more vapor pressure at the surface, right? That more of the entropy is happening at the surface. That energy exchange is happening at the surface, so there'd be more pressure there.
The water vapor is less dense, and so it rises. This is what it naturally does.
But it's causing pressure. Yeah, but it's causing pressure. It's called vapor pressure, right?
Well, if it's rising, it has to be causing pressure, right?
Exactly.
What they have to do is confuse pressure with density. Okay, water has a certain density. Period. Water vapor has a certain density. Oxygen has a certain density. Okay, they're just trying to confuse. They're trying to override a little bit of air pressure, not air density, but air pressure. With they're making this. They're making it. What they're really doing is making it where their sun can be actually have set almost an hour beforehand, yet still be visible on the horizon. Then they want to go religiously by the shadows that sun creates, but say, no, the sun's not really there, but it's creating the shadows, except on the selenium eclipse. Then the shadows don't follow that rule. They want to say, look, they want to point at your eye and your finger and the shadow and say, hey, that's where the sun is, because look at the shadow. Except for during a freaking eclipse that kills their whole entire model. They're desperate. They're grasping on the straws. I'm sorry, I'm having a tough time clarifying.
So you're saying that there's something that happens with the shadows on the selenium eclipse or at sunrise and sunset that is different than what happens during the normal course of day? What's the difference?
Well, when we see the sun and the moon above the horizon, they say the sun is not really there. It's actually set. Yet we still see the sun rays. We could still put on some suntan lotion. We could still get charge from our solar panels. We still see the sun. We still see the shadows, but the moon doesn't see it. Go figure.
But they're both close to the horizon, right? Because that's where supposed for refraction to make things that are below the horizon to still be seen.
Here we go again with your reflection,
it's not all
Bacon. We
the
did that
time.
earlier.
Yeah, well, that's the subject of now.
Right.
So
You claim refraction, but you can't do that. You try to.
no. I'm not claiming. I'm just saying that this is not something we just come up with when we don't account for observation.
It's definitely something that you come up with. No, you said that actually right the first time. You come up with this shit, you guys.
Well,
No, it's explained. It's explained.
It's ad hoc.
And
It's
it's
ad hoc.
Not ad hoc.
That's
Not
the
ad
point.
hoc.
It's explained. It's not demonstrated. I've asked this so many times for the past 5
It's
years. Can you show
demonstrated
me
and
something that's
explained.
behind something being refracted so I can see it?
Please.
Yeah, there's multiple examples.
Now, show me.
Well, the point was the situations in which things are going to appear to be at a certain position and they are not there is when they're close to horizon. So because you have a lot of atmosphere in between them, if they're away from the horizon, then you have barely no refraction. So in the example of the eclipse, they were both close to the horizon, right?
It's okay. We're
So-
on our illusion, what we're seeing, right? We're not seeing the moon. We're not seeing the sun. We're not seeing sun rays. No, it's all refracted, right?
So that's
Yeah.
not
Well,
the sun. That's 8
it
minutes
must be.
ago, and that's not the moon that we see. That's what you're telling me. That is not the moon, and that is not the sun. So
Yeah, it is.
Muddy,
It is the
Muddy,
sun.
become the sun.
listen,
Sorry, quick
listen.
question.
Muddy, we can
When
make it.
does the sun become the sun? There's the actual sun.
It's
Or
always
when
the
is
sun.
that the actual moon that I see? Because that's not the moon that I see in your idea of refraction and the selenium. So when does
Oh,
it
it is the
become the
sun.
moon again?
It is the
You make
sun,
it
and
muddy.
it is the moon.
No, you just said I was
Yeah,
not seeing
and,
the sun and the
your-
moon because it's
Your own
refraction.
model claims that the sunset is an optical illusion. Do you disagree with that?
No,
Claims-
no, that's wrong.
Claims it's refraction.
Oh,
Every time
okay,
you
so wait
see,
a second. Hold on, just to clarify. So the sun appearing
need to
to go
clarify.
down, the sun appearing to go down into the horizon is not an optical illusion. It is actually touching the ground there. Is that correct?
someone's trying to explain something. You don't have to repeat yourself.
There you go.
The-
So there's an optical illusion, right,
the
Ben?
sun, when you see the
Not an
sun,
optical illusion.
when you see the
So
sun,
it is
regardless of the
not-
light
wait.
rays,
So,
light
Tina,
rays are coming. Jesus Christ! Dude.
so when the
Light rays are
sun
coming
appears
straight
to
into your
touch the
eye.
ground, Tina,
Data, you gotta let him respond, Data.
Hey, listen, can we have like Jedi come back into this discussion?
Yeah, when you see an object,
Your mic really went really bad, Data. Data, your mic went real bad.
when you see any object, including the sun, light rays from the sun or whatever, you see a computer screen, anything, if its light is coming straight into your eyes, it's still the light being reflected or emitted from the object coming to your eye. If it came in a straight path, then it came in a straight path and you saw it, you saw the real object. If it came in a curved path, the same thing occurs. The light is being emitted from the sun, it's just coming at you in a curved path. You're seeing the real object. You're seeing exactly.
Sure.
There's nothing fake
Again,
about
I'll
it.
ask
There's no
you.
optical
I'll ask you.
And it's not
Does the
rocket
sun?
science.
Does the sun actually touch the ground, or does it appear to touch the ground, Kosho, when it's
How
setting?
old are you, Data? What kind of question is that, Data?
Shut up.
It's
Shut up.
93 million miles
Shut up.
away.
Take a
It's
sleep.
93
Shut up.
million miles
It
away.
is an optical illusion. It is an optical illusion, plain and simple. Kosho, I'm going to ask
What
you
illusion
again.
there?
You appear to be intelligent, but it's a very simple question because in your own model, it calls it an optical illusion and it gives you an example of refraction and why it's an optical illusion. I'm going to ask you again. Dude, you can go research it yourself. Just take the time to type it in. Is the sunset an optical illusion? You'll get an article on it. The point is it is an optical illusion because there's two factors here. The factor is the sun is apparently past the horizon and it's being refracted up into a position which so it's not there. It only appears to be there. That's one. And number two, it appears to touch the ground. So those two optical effects, that's what it appears to do, right? And your model says that it's an optical illusion. In flat Earth, we know it's an optical illusion, right? The problem is
It has to be an optical illusion because you have no other explanation for it other than to wave your hands and come up with some sort of.
So you have
we
have two explanations. We have an explanation. Would you like to hear it from me?
Oh, please tell me about the Aether Band again. I love hearing bullshit.
Yeah. So the apparent
Everybody
conjunction.
drink.
Yeah, the apparent junction, pardon me, of the sky and ground is an optical angular limit. The ground is apparently rising up into a neutral point of our eye, which is perspective, which means the angles of light are compressed into a finalized vanishing point due to our height. As we change the height, that angle it opens up and we could see farther. Basically, it's the angle of light based on the height to the eye. That's why you get this convergence point. The top part is to do with the atmosphere. If you want to just indulge me here for a second, I'll use your sphere part of it because it appears to be that way due to the way that light bends downward due to refraction. So we have two combinations. We have perspective, which gives us the explanation of converging lines of light to appear to converge, and we have the upper atmosphere to express as refraction. Just like you do in your model, except for the apparent junction is caused by Earth curve. In ours, it's an optical limitation to the eye. So it's the same explanation, just reversed.
Except there's no such thing as optical limitations to the eye. It's just gibberish.
Optical
listen,
limitations to the eye is gibberish?
Yeah,
Wow.
that absolutely just demonstrates that you should have no place in this conversation, Brender. That comment is absolutely asinine.
Now, explain what an optical limitation is.
No. You denied that it was possible. So now, do you affirm? Listen, do you affirm that your eye is able to see without distortion, limit, or acuity?
My eye can see infinitely far away.
Oh.
There are no optical limitations to the distance that I can see.
Prove it.
Yeah.
We don't send our
can prove
vision
it.
away. The light is being sent to our eyes. It doesn't matter how far light travels.
They don't understand. So
No,
I
we
can
do
see,
understand that. Hey, Brenda, weren't you just last night on Discord telling everybody about how perspective is all psychological?
No, I wasn't. I was
Yeah,
telling
you were
No, I was
making
telling
snide comments
Gleam-
about how it's we're talking about psychology when we're talking about optics.
I was telling Gleam that the papers he was showing were about the psychology of perception.
No, they weren't. They were about optics.
Yeah, they actually were.
Actually, no, they weren't.
Talking about how people, because they talked to people and asked them questions and got their subjective input about what they saw, what they thought they saw, what they were judging. That was all about psychology and a person's subjective point of view. It was not objective optics.
What is objective optics?
How light travels, how it is bent due to lenses and due to Snell's law and the other how it's diffracted and diffused.
But perspective is not psychological.
does
Would you agree with
context-
this statement?
does
A perspective is not a psychological phenomenon.
Yeah, I think it actually is.
No, it's not. Have you ever taken a picture?
Why not? Yeah.
Did it have perspective in the picture?
Yeah.
Do you think that your brain transposed a different image from the picture to what you saw?
The reason that there's perspective is because the camera is built like the eye.
No, that's because that's how the world works. That's how optics work. That's how we see the world.
Well, things get
It doesn't
smaller.
matter what sensor we use.
Their angular size reduces as to their distance away from us. That's perspective.
Yes.
That's all perspective.
And that is not psychological.
Our judgments about it are psychological.
Our judgments about it
you're
may be
talking about
psychological, but the way the world works,
Yes.
with the way we see the world, whether with a camera or with
We're
our
not
eyes,
talking about interpretation.
whatever, is not psychological.
Neither
Ladies
is
and gentlemen,
was publishing was all about interpretations and psychology.
Ladies
not
and
about
gentlemen,
I'm not worried about that anymore. I'm just asking you for your opinion.
Brenda the donkey.
Sorry, guys, I missed. Go ahead.
Ladies and gentlemen, I give you Brenda the donkey. Donkey talk with Brenda. Up next, rationality with Brandon and the plain truth.
Hey, Gleam, what's going
this
on,
could
man?
have been this could have been a much more simple conversation if we had established at first that we were talking about interpretation of images, right? But that's not how this started. It was always about perspective is psychological. That was the blanket statement.
Well, yeah, it mostly is. Yeah.
Hey, Brenda led with "We can see infinitely." We can
No,
see
it's not. It's not.
infinitely. That's-
It's not mostly psychological, Brenda. It's not true.
Hey, Brandon, are we live right now?
Yeah.
Thank God.
Yeah, that was great. That was
Yeah,
great.
so-
We can see for infinity and beyond on some Buzz
Yes.
Lightyear shit.
Yes. I can see the galaxy on the belt of Orion that is millions of light years
Stop,
away.
Brenda.
Yes, I can see it with my naked eye. You can
I
see it
don't
with
care
your naked
how
eye.
far away you think it are. Some people think they see fairies floating around out in the woods. No offense
this
to them
is
either.
Not
Brenda,
this is
Brenda,
not
if it's millions
a
of miles
delusion.
away, Brenda, if it's millions of miles away, how come I can make it bigger with my freaking camera? I can make the point source like this millions of light years away. Same
That's
thing
what
with
lenses do,
Aristarchus
Brian.
crater. Same thing with Aristarchus crater. It's supposed to be 60 miles across, yet I could zoom in on it, okay? When I try that here on Earth with a mountain range 60 miles wide from 270 miles away, it's already half the size of Aristarchus crater.
Are you saying that lenses don't,
Live.
are you saying that
Live.
lenses don't work, Brian? Are you saying lenses don't work on Earth, but they do?
No,
in
I'm saying
space?
light years. Brendan, I'm saying light years don't work.
Well, you can, with a lens, with a telescope, get a larger view of the galaxy in Orion's belt. So
You're not getting a
that's how
larger view.
things work.
You're just magnifying the
lenses.
light that is making it to you at that point.
Yes,
That's all you're doing.
yes,
Yeah.
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 Brian-
Why is that?
Brian's amazed by
Is
that.
that a problem? Is that a
No.
problem?
Not at all.
It's a
Well,
problem.
It
with
is for
Aristarchus
Brian.
crater.
Brian doesn't
It's a
understand
problem. It is a problem. It's a problem
not a
with your
problem,
when
Brian.
you say that Aristarchus crater is 60 miles wide and 240,000 miles
Listen to
away.
me, Brian. I
Because
call
when
you
I take a mountain
bullshit.
range, take the world
I
record.
call
what?
bullshit on you. You bring me an evidence that what you say is true.
Well, let me just walk you through it.
Don't,
Take the
don't
world
walk me
record
through it.
observation.
Show me the observation.
Yeah.
Not what you think, what you remember
Whatever,
you
Chuck.
saw, but what
No.
we can
Have you
see.
gotten your evidence yet, Chike? Have you
Oh,
gotten the
I
evidence
have.
for us yet,
I
Chike?
presented it yesterday here. Nobody dared do the math. Did you?
Huh?
Did you?
Chikey,
I gave you
listen, go to J-Total
I gave you
Medium,
the
okay?
focal length. I gave you the size of the image, and you couldn't do the math. And I guarantee you, it
J-Total
would walk
Medium
on
has
Earth just as it walked on the moon.
He don't want me to talk. I guarantee you that because
No, talk,
J-Total
talk.
Media has Lake Okeechobee. Okay, that's half the size of Aristarchus crater. He has it from about 500, 600 miles away, which shouldn't be happening on a globe. But he has Lake Okeechobee in Florida. Okay, which is almost like a little over half the size of Aristarchus crater. Now you tell me that Aristarchus crater is 240,000 miles away. How come dude? Do the math. Line them up. It does not work, buddy.
Show me the images. Show me the images. What focal lengths they were taken with? Do you have any knowledge?
Don't talk about focal length, Chike, because that's what you was missing.
I
You
was
said it was
missing-
82 pixels, and then when I was asking for the focal
84.
length,
84. I said it's
whatever,
900.
yeah, you
I
only
said
gave
it's
an 84
900,
pixel
like
measurement.
a million times. I said it's 900
900 what?
millimeters.
900 millimeter camera.
I said
Lens.
focal length.
The focal length of it, because I'm sure you
I
were
said
saying it
focal
was
length. Don't
it
be
was
sure.
that
I
2
know what I
megapixel
said,
camera. It was
because
the
I
2
have nothing else.
megapixel camera, wasn't it, Chike?
I have nothing else but 900 millimeter focal length. Can zoom in, can zoom out. It's fixed.
Does Gleam know what focal length is?
Well, anyway, I only
bet
came
you-
in
I
here
bet
to
you don't.
defend. Yeah,
I bet you don't.
I do. But anyway, Brenda, I
Like
come in
today.
here to just literally ruin you and just show. Can I share my screen, please, Brandon?
Of
Is that
course.
okay?
Yeah.
So all you did is show links.
To this paper. Do you remember this one, Brenda? Because if we look here, it kind of says here. Brenda said, Gleam. That's all about lens distortion, you moron.
Huh.
Yeah. And then in the actual document, it says lenses are way more complex, and the complexity of lenses is beyond the scope of this paper. So in this work, we focus on the latter type of distortion, which has an important role in photography, image reconstruction, and image measurements.
It's all psychological.
Yeah, it's
That's
all
what she says
psychological.
today. She must have changed her story. It was about lens distortion the other day. Today it's about psychology. It's interesting.
Yeah, she doesn't obviously know what photogrammetry is. And didn't obviously read the paper because it's exactly to do with a camera. It's a monocular camera, you idiot. That's what it's analyzing. And this is NASA. And you literally, I've quoted you multiple photographs of a perspective scene reveal the principles of picture perception.
What is this guy, a
Photographs.
doctor of Casper Erkelen's? I've read
Psychology.
a few of his papers.
Robotics.
Psychology. No, you got the wrong one. That was
Oh, it's the other one.
Theoridus.
Oh, he's a master in
That's
psychology.
him. That's
He's
this
in
guy.
This doesn't
it's
look
in
like this
psychology.
paper doesn't look like it has anything
Yes,
to do with
this one
psychology.
here, experimental psychology.
Yeah, psychology.
Multiple photographs of a perspective scene. Yes,
Yeah, about psychology. Right. Isn't that right, Gleam?
about
It's about
photographs.
psychology. Yeah, about photo. It's the psychology of viewing photographs.
Is this? Or is it the measurement? This is the one I give you, Brenda. You haven't seen this one before, but I was just showing that. But this is the geometry of the physical scene.
I don't think I've seen this one before.
It's the psychology of viewing
No.
photographs, right?
It's not. It's the way how focal length works, Brenda.
Really? So why didn't you give
Look
me an
at the
answer?
focal length, focal length, focal length, focal length. They're all different. And he's changed the field of view and cropped in. What he's basically saying is that the focal length is just a crop.
Right. Exactly. It's all you're doing
Focal
is
length is a
magnifying what's
crop?
the light that's getting to you, right?
Mm-hmm. Yep. Well, it's just, look, he shows it here. He shows that picture there, when he's got the focal length set to that, turns out to be this picture here.
It doesn't change
this
any
one.
of the aspects between things or the
No, it just
relative
crops
size
in on it.
between the objects.
Yeah, so can you give me the answer now?
Right,
then,
but
if you
anyway,
know
no,
about
wait there,
cockroaches?
Brenda. Brenda has got to admit that she doesn't actually know anything about this, and she's just winging it.
Of course she is.
Because that is ridiculous. Saying
what
that
is
it's all
what is
about
focal?
this.
What is focal length?
What does it matter when you're saying that you do not have a limit of your eye? That is so stupid. Look at this.
Why
You
is
can
it
just
stupid?
go visual acuity.
I'm not talking about acuity.
Do you know why? Well, okay, explain why glasses were manufactured.
Yeah, but
I'm
that's
not
not a
talking.
distance.
Yeah, that's not a
Explain
distance.
explain why glasses were manufactured then.
What does that have to do with the distance that I can see?
Because some people need glasses because they can't see that far in the distance, Brenda.
What does
Did
that
you
have
not
to
know
do?
what glasses are
No.
made for?
They're made so that you can resolve, right, distant
Right.
objects.
Why would you need to resolve if you can see into infinity, mate?
Well, there's a difference between the light reaching your eye and your eye's ability to focus.
Okay. Is there?
Right?
So there's a limitation,
Yes.
is there not?
There's a
But
limitation.
2 minutes ago,
You're
there is
talking
no
about
limitation.
something else.
So
You're equivocating.
You said
you're
there is no
equivocating.
limitation
There's
in
no
perspective.
limit. There's no limit to how far I can see. There is a limit to how much my eyes can focus. Birds can see farther than humans.
So you think you can see
farther than
over the
infinity.
other
So
side
humans,
of the
if humans can
universe
see, hold on,
with
if
your
humans
eye.
can see, hold on, Gleam. If humans can see for
Why-
infinity, birds can see farther than that.
No, dude. There's no limit to
No.
the distance that you can see. There's a limit to the size of objects that you
That's
can.
what Brenda.
It's not
Birds-
size because a
I'm
point source
saying-
light.
I guess there was no
through.
reason to have like a little what do you call a microscope, right? I mean that doesn't really help, right? If we
Yeah,
can see
exactly.
anything, we have no
It lets
None
you
of
see
that-
no
things that are small.
we have no optical limitations,
None of
right?
I'm saying
that.
that the limitation is not about distance; it's about angular size.
So there is a limitation then, yeah?
Yeah, but it's not
Oh,
distance.
cool.
Yeah.
Yeah.
There's no limit. There's no limitation, Gleam, to how far I can see.
You don't
There's
know
a
that.
limitation. There's a limitation
sure?
to how close I can resolve an object.
When you
Yep,
said
so
birds can see
overlapping.
farther than
Those
you,
are
right?
two different things. Those
Right,
are two
Brenda,
different
you said
things, and you're
bird-
getting confused about
No,
them.
they all
They're
they are all
different
part of
things.
the optical device.
My resolving power is different than my ability to see
That
distant
is
objects.
your limit that they're
No,
on
it
about.
isn't.
It
No,
is.
it isn't.
Light
No.
attenuates. Period, Brenda. Light attenuates.
Yeah, but if there's a larger object, it doesn't matter how far away it is if it's sufficiently big enough. That's what the point is. That there's not a limit to the distance. There's only a limit to the angular
Look.
size of an object.
How big are black holes? And why
You
can't we
increase
see
the
them?
resolution.
It's not to do with that. It's to
Black
do with
holes
light.
don't emit
You
light.
just said 1 minute, light comes to my eye, and then
Yes.
you're saying if it's so big, no, it doesn't. A point source of light can reach you, no matter how big the thing is. You cannot resolve it. I mean, the
It would
ISS
depend on- it
is a
would
perfect
depend
thing.
on- It would depend.
They don't
on how
understand
bright-
that they don't understand Gleam, they don't understand that the eye is a sensor and the eye can only absorb a certain amount of light based on the size of its sensor.
That's
They
what
don't
we're
understand
talking
that yet.
about, dude.
still
That's
see-
exactly
I can-
what we're talking about.
And that's
We're
the
talking about
limit.
the angular
But
size
I
of an
can
object.
still see.
That's the limit.
I can still
the limit of
see
your pupil
the
as well,
galaxy.
because you
the
cannot
galaxy.
see every single star in the sky, even if it was a clear night.
Why can I see the galaxy in Orion's belt? Why can I see that?
Oh,
Gleam?
why?
Can you not
It-
see all the stars and all the
Gleam,
planets ever
No,
with
answer
your
the
eye?
question. Answer
No,
the
because
question.
that is the ultimate
No.
question. If you haven't
No,
got
it's
any
not an
limits,
ultimate
why
question.
can't you
It's
see
a
everything?
child's question. Why can I see the galaxy in Andromeda? Well, I think it's the
Because light
Andromeda.
reaches
Oh,
your
why? Oh,
eye,
why? You're
Brenda.
looking at light. The point
Now
is,
answer
Brenda,
my
is an
question.
object.
Yeah, now answer my
is-
question. Why
it
can't you
is
see all
millions-
lights in the sky?
That's not what we're talking about. You're shifting goalposts. You keep
I'm not.
shifting goalposts.
I'm saying
You
that there's a
are.
limit which stops us from seeing all lights in the sky, Brenda.
No.
No, that's not why. That's called Oberon's paradox, and I think that's what it's called. and it has nothing to do with our
What?
ability. It has nothing to do with the sensitivity of our eyes.
So
Yeah,
light
you don't
doesn't
know
get
jack
scattered.
shit. You don't know jack shit. until you
Light
see it.
doesn't get scattered. Is that what you're saying?
Getting scattered doesn't have anything to do with our eyes.
I can see
Light's
Andromeda
coming
Galaxy,
from the other side of
Oh my
the
God, can we move
galaxy that is massive. You're saying this object can be massive. Yeah,
there's
the
no
light getting to our eye, yeah, can be scattered, and we don't get it.
There's no arguing with a sociopath. Can we move on?
It is crazy. It's crazy just because you just couldn't
just because you
admit
don't
that is
understand,
exactly
like,
about cameras.
This is stuff that you teach like 7th graders, and
Hold on.
you can't understand it.
They're
Why
gonna run
can't
away
I? I
from it.
just
They're gonna
explained
run
it
away from
correctly.
No, but this is the main point. Again, so you're not, don't mix it up. No one's saying
You're the one
that,
mixing
there's not
up.
limits. No one's
You're the
saying
one
there's not
mixing up.
limits. No one's saying there's not
I'm
limits.
posting papers about cameras, and you're saying it's
hold on,
psychology.
You have to run your mouth for a second. I'm saying my final word about this before you guys run off like pretend like you fucking have some
Final
fake
word.
victory.
Go on.
Yeah, for the last time, there's no limit to the distance that you can see. The limit is about the angular resolution of the angular size of an object.
Would you
It's
say a
just your angular
vanishing point
resolution.
is a distance-based?
No, a vanishing point is an illusion.
Is a vanishing point based on the optical device limit?
It's based on your yes. If you get a camera and zoom in, you can
Thank
move
you.
that vanishing point.
Bye.
Yeah, you can move it.
No,
Right?
you can't.
But-
Cannot
That's
move
a
the
limit.
vanishing
You can.
point.
Yes, yes.
Show,
you move
show
it
me,
by
show
zooming
me,
in.
show me an example of moving the vanishing point. Then
There's if a larger object if a large enough object appears where the vanishing
Okay,
point
shut up,
was, you can
Kosho.
resolve it.
Kosho.
I mean, everyone knows this. This is clear.
show
clear to
us
everybody.
an example of moving the vanishing point.
Go ahead, look at the Hubble telescope deep space images, and you'll
What's
see
that going to
how
prove to
the-
me? You guys think we're on a
the
floating
vanishing
ball?
point
I
there is
don't.
the other side of the universe.
Yeah, that's what you say. That's your fucking claim.
It is.
Yeah. You gonna use one
you
claim
can't
to
show it,
support
basically.
another claim?
Okay, wait. Hold on. Let's just back it up for me, okay? Chike, what the fuck did your explanation demonstrate? Like, I can't see what you're talking about. Brandon again said to Brender, "Show me," and then we get Kosho puking all over us, and then we get you puking all over us. Show us the vanishing
Because you're not listening.
D-Ball has just put it in there. Look, BBC saying that the absolute farthest object we can see with our naked eye is outside our galaxy, the Andromeda galaxy,
let us respond to
located
what he just
2.5
said.
million light years from us.
Let him
Well
respond
done.
to what he just said.
We can see it from the other side
Yeah,
of the
thank you
universe.
for backing up everything I've been saying.
Right. So
23 quintillion miles, huh?
The vanishing point can be some. Let's say you're on an island or something. You're looking in the distance. Everything is too small to resolve, and that would be in your vanishing point. If for some reason some large, like a mountain, appeared out of the water, or ship, or something that was large enough to be resolved at that same spot, it would no longer be a vanishing point. There'd be
Show me you optically moving the vanishing point. That's what the claim was, that you could zoom in on something and optically move the vanishing point, wasn't it?
I want to say something, Brandon.
Just
Hold on. Hold on.
here on Earth. Just show it.
Yeah, on Earth.
Can you
Show
see
us the
Plato?
vanishing point.
The-
You manipulating the vanishing point.
I posted the picture yesterday. Can you see Plato with your eyes?
Dude, honestly.
Can
Get
you
out of
see
the
it with your
fucking...
eyes? It's vanished.
Get out of space, dude. We're on Earth. Earth.
That's too small for vanishing points.
So can you on Earth manipulate the vanishing point and move it by zooming in?
No, there is a horizon before the vanishing point.
You can't
when
see
you
the...
take-
Yes, you can very rarely see the vanishing point for a number of different reasons. That's true.
Well, no, there's not a single.
There is
vanishing point.
always still a vanishing point.
Image. There could be they could be 5, 6. There could be multiple vanishing points. Having one vanishing point is something you do like in art class.
Dude, that is besides the point.
Back that up.
From one single point, when you look out and see a vanishing point, show me you zooming in and changing it.
There's no. I want to challenge Kosho. Prove that there's 5 different vanishing points in an image. Prove it.
You have more than 5.
Okay, fuck. Prove it.
May I
Dude,
say something?
You get so angry at shit that you sound stupid in, and then I want to show it to you, and you're just gonna pretend like you're a victory. I'll show you right now. I'm showing it to you right now, man.
So
Any art book.
you've been asked, you've been asked to show something, and then you say your answer was you're not listening. Do you understand that showing and explaining are 2 different things, right?
Yeah, I'm explaining something to adults that should be obvious.
Come on, go shush.
That whenever there's a vanishing point, and then there's an object that's there that's large enough to resolve, it's no longer going to be a vanishing point.
We know what you're saying.
But you guys.
No, we know what you're saying, and we agree
hear
with you.
explanations every day. We hear the same
You're
explanations.
being silly.
Come
There's
on,
nothing
Coach
to do
Joe,
with a
stop
vanishing point there.
Yeah, stop pussing out, Kosho. Where is this proof? Where did you post this? Because I don't see it in general. Is it in general?
Where?
Really taking the position that there is no angular limitation to the eye or resolution limit to the eye is ridiculous.
Tell you right now,
That's
he's going to show
not the
multiple
position.
objects.
No.
I never said there was no angular resolution limit to the human eye. Never said that.
would be the
Yeah, you said
don't listen.
you said there is no limit
No,
to what you can see. You said
There's
That's
no
correct.
optical limit.
That's
there
correct.
was no
That's correct.
limit to what you can see.
It's
That's
incorrect.
That's incorrect.
People for Life
that's
just
correct.
cited
There's-
BBC saying you're wrong. There is a
No.
limit to the Andromeda Galaxy.
There's no limit to how far something away can be.
Oh, fuck that.
Okay,
And they're
fuck.
invoking fucking space
Yeah.
and shit
Now we
23
gotta
trillion miles
fucking-
away. It's so
Brenda
stupid.
just said something retarded. There's nothing. What did you just say, Brenda? An object. It doesn't matter. The object can be as however far away. It doesn't matter how far
It
away the
doesn't
object
matter.
is. Is that what you
What
said?
matters, it would depend on its luminosity, right? So if something is highly luminous, then we could see it.
You're flaking. You're
And
flaking and
it's-
spiraling.
No, if something is very
Wow, you ain't got a
intensely
clue.
bright, excuse
ain't
me,
got a
I'm
clue.
talking. If something is highly luminous, very bright,
Yeah.
if
So
it-
Brenda,
if
you
it's
can have
bright
something
enough-
really small. You can have something really small and really bright, right?
Yeah, like
Or sorry, you can have something. You can have something really small and really bright, or something really big, really dim, or you can have something really close and really far, and represent the same scenario for both, which is the luminosity and size ratio. You wouldn't be able to tell unless you actually went to the object. You would be begging the question as far as the luminosity value and the distance to that object and its size. You would have to beg the question of one or the other. We're not talking about that. We're talking about the limitation to the angle of the eye. We're not talking about whether an object's luminosity reaches the eye. You still
that's
have
what
no
I've been talking
determination.
about.
You still have no determination to the distance. So you're gonna have to
That's
beg the
what I've
question
been
for that
talking
one. Let's talk about actually the angular
So,
limitation that you have
I
to
have not
objects.
been
For instance,
talking-
Brenda, let me
I've not
give
been
you an
talking about
example.
angular
Let me give you an example.
limitations.
Yeah, let me give you an
I've-
example.
I have
Okay, so
not
you're
been talking
clear.
about that. So you're straw
Let's
manning
keep
me.
you. Let's
Stop
keep you down to
straw
the.
manning me.
Let's keep you down to earth here, bud. So listen, you got 2 fire trucks, one on the ground, one above, and let's just say for this example, we're elevated 10 feet in the air, 15 feet in the air, so we can visually see the fire trucks above and below our neutral point. And as those fire trucks, big red fire trucks, proceed away from us, Brenda, what are they going to appear to do? Do you know? I know. They're going to appear to converge, right, Brenda, into a vanishing point, right? They don't actually really
Do they?
converge or any of that stuff.
Do they?
They don't,
Do they?
right? Because why don't they? Because there's the visual acuity involved, which means there's an angular limitation to light. Why is that? Because your eyeball is
There's
a
no
sensor
angular
of
limitation to
your
light. There's an
eyeball is
angular
a
limitation
sensor.
to your eyes.
Let me finish, bud. The let's say the light and the construct of angles of light to the human eye. Your eye has an aperture that has only a certain capacity of light to enter it. And because your cone of your vision is a convex lens, it's going to produce a convergence, which is displayed in the diffraction limit. Do you disagree with
Yes.
that, Brenda?
Yeah, none of that has anything to do with perspective.
It has everything to do with optical limitations, right?
Right. The angular size of the aperture through which you're using, whether the human eye or a camera,
It
will
has
determine-
everything to do
will
with
det-
optical
excuse me,
limitations, right,
excuse
Brenda?
me, Excuse me. Yes,
Brenda,
it will
does it have?
excuse me. Stop.
Does it have to do with optical? Just be honest and answer the
Data,
question.
Data, hold on, Brenda. Data, let
Interrupting.
Brenda, let Brenda go.
So the angular size of the aperture that you're viewing through determines your ability to resolve an image, right? And I am not talking about
And that's
that.
based on visual light, right? It's based on the light, the luminosity of that light. If you have a point of that
It's
light
not
where it
based on the
diffracts,
luminosity. It's not
gonna
based on
create a
luminosity.
banding. It's based on, if you have no light, you're not going to see the angle to it. And in fact, the less light you have, you can't see as far, right? So it has everything to do with light and how the receiver of the eye is getting it.
But it doesn't
So
have
if you
to
have,
do.
it
So
has
it-
everything to do with
it
the
has to
size of
do-
the receiver. Your
has to do with
eyeball
the
has a
size of the
constant.
aperture, right? The size
Yeah,
of the
yeah.
aperture, right?
Yeah.
Yeah.
Uh-huh.
I'm not talking about that. I'm
Yeah.
simply saying that there is no limit to how far away something can be for that light to eventually reach my eye.
Yeah.
So you
then
think light
diffraction.
doesn't? You think there's the attenuation of light isn't a thing,
Yes, of course it is a thing.
which would make it impossible to see
limitation?
forever.
It would,
It would make
so,
that would make it impossible to see forever, wouldn't it? Infinity, like you said.
So why
so it
why
makes
is it
it
that
what
don't
it, what
save
it
her.
would
Don't
depend
save her, left
on.
lane.
What it would depend on is the luminosity, right? A candle next to the Andromeda galaxy, I can't see and never will be able to see, but I can see the Andromeda galaxy because
Sounds like
it's
a limit to me
composed-
there, Brenda.
because it's composed of suns. Yes, it's a
Can't see past
resolving
that,
ability.
can
So
Yes,
there's a
I
limit there,
can.
Brenda.
I could.
Okay, listen.
I could
listen,
if
we
there
need-
was an
again,
object bright enough. If there
Again.
was an object brighter in the sky than the Andromeda galaxy, we could, and farther away, we could see it.
But we
Okay,
can't
now
because
again,
there is
Brent-
limitations.
yeah, Brenda
Yeah,
has now,
right.
yeah, Brenda has now just spun the entire conversation again. Can we move on from here?
I haven't spun it. I've kept it on topic. You guys have careened
No.
from topic to topic.
Okay, let's move. Let's move past
Just showing
this.
you at
Move
least
past
3
this.
limitations that you stupidly forgot.
Yeah, guys, we're arguing
Those
about
were
how far we
straw
can
man.
see in space with Brenda. What's this
Visual
one?
acuity is a straw man about how far we can see distance-wise.
It's a straw man about what I was talking
Stop
about. Dean.
talking, Brenda.
Listen, light attenuates. You can't see forever.
If it's bright enough, you can see it.
No, the light.
Jeremy,
Oh
you're
my
right.
God.
It's
You're
bright.
right, Jeremy.
Oh my God. What the fuck? Listen, okay, Brenda, what you just said was a non sequitur. What Jeremy said was one thing, and then you responded with something completely not related to what he just said. Can we please move on from this?
What I said was related to what I'm
No,
saying.
it was not. Shut up.
Jeremy,
That's all
you
you
already
ever
made,
say.
like-
you just scream at people.
Brenda, you already
Jeremy.
made
Yeah,
like 3 or
I'm
4 numpty
screaming
clips
right now.
tonight.
Yeah.
We're gonna just take a
Yeah.
little break.
Jeremy, you're correct. We can see forever because the universe is
Isn't this
only.
all Brenda though? Just based
You
on
had to
conclusion
talk
in your
over
mind
me, did
that you're
you?
making?
Did you?
Hold on, let
It's
Chuck
down in
finish.
your bones
I
to
didn't
talk
even hear you
fucking
at the
over
same
me.
time, honey. Calm down.
I
Go,
was
Jay, go.
talking. I was half into
Go.
my sentence.
Go.
So Jeremy, you're right. You can see forever. The universe is 313
See, again,
billion,
Mikey,
800
Mikey, you don't
years
need to say
old.
this, but this point's
We
been made
can't
5
see
times.
behind that.
We're not going to
But
argue
to
with
get
you about how
Hello?
many trillions
Hello?
and quadrillions
Yeah,
of miles
I
we
couldn't
can see
finish
out
it.
in
I
space.
couldn't finish my sentence, right?
That's because I don't want to hear it again for the 10th time.
No, you didn't hear it once.
I did.
So you
Brenda
can see
said it. You said it.
13 billion,
I think Kosho said it.
13 billion.
T-Ball
13
posted
billion,
something about it. I'm not
800
going to sit here and argue with you about how far
light
we can
years
see out
away.
in space.
That's our limitation.
Don't care. It's already been said. So anyway, what were we talking about on Earth?
We're talking about what causes the limit to what you can see. It doesn't matter if it's in space or not. But the things that you guys are talking about, like the light not being able
Oh no, we were
to
talking about.
your eyes. Hold
we were
on, man.
talking ab-
Hold on,
Yeah,
man. Hold
you
on.
couldn't
Hold
wait.
on. Yeah, so the light.
No,
the
we were
light not,
talking about
hold
the
on, hold
Solid
on, dude. I'm about to get it out, dude. Just hold on.
No,
But talk
please
about the
don't get it
light
out.
being able to talk about the light being able to reach your.
Excuse me while I whip this out.
Let him
Okay.
go.
Wow.
Come on.
Go ahead.
Okay, so
Please stop
the light,
exposing yourself.
the light not being able to reach where you are because it's not powerful enough. That is an issue that will cause the light you not be able to see it. Okay, this is one thing. Another thing is if the object is too small for your optical device or your eyes to resolve the angular size of the object, that will also cause you not to see it. Now, what's not available here is the distance, an actual hard distance that is that limits your eyesight, because an object can be powerful enough to send the light to your eyes, and it can be big enough to be resolvable, and it could be, and if both these are sufficiently true, it could be however far away it needs to be. So there's no limit to the distance that you can see. Those limits you guys are talking about are other limits.
Yes, Kosho said exactly what I was saying. Thank you very much, Kosho. I really appreciate
Okay,
it.
so where the earlier conversation, we were talking about the selenilian, and we were talking about the apparent positions of the sun and the moon earlier, and then this whole thing got sidelined somehow.
Data did that.
Yeah,
I mean,
usually
we've talked
does.
about the Selenalian before. You guys always claim that the sun that we see is the apparent sun during the sunset, sunrise, and not the actual sun. We're not seeing it in its actual position. The same thing is taking place on the flat Earth. What's the problem?
Well,
There's no
data was-
obstruction on the flat Earth.
Yeah, Data was calling
It's
that an
refracted,
illusion.
so you can't see
I
it.
just disagree.
What do you disagree with?
That Data was calling the fact that the light takes 8.5 minutes to get to your eye, and I mean, you still see the sun, or even if it's refracted over the horizon, you still see the sun. To me, that's not an illusion. You're just the light's just bending.
Well,
It's coming to your eye.
I think it's a semantics issue at that point. If you
Yeah.
call it a optical illusion, or
Let me try
if you
this
just
example,
describe it as
Brandon.
the sun
No,
not
please
being
don't.
in the
Please, dear God.
seeing it in an apparent
suppose-
position
Well,
and not its
here's
actual
why I call
position.
it here's why I call it
Goddamn.
an optical illusion, is due to the fact that it appears to touch the ground.
No,
That
no,
Every
we
person
know that
go
doesn't
around the
happen.
corner, touch
So
the wall.
hold on. So optically, it looks like it's touching the ground, but we know logically it's not, right? So that to me would be considered an optical illusion, would
Okay,
it not?
Yeah, he's explained what he means by optical illusion. I think that's fair enough.
So
I
every
understand why
car-
you're saying it's not an optical illusion, but I think in a sense it's a semantics issue. So he's defined what he means. It's okay if we call it an optical illusion based on his definition, isn't it?
Brandon's making a good point that the arguing about whether it's optical illusion or not is irrelevant, but arguing about whether or not you're seeing the sun or the moon or whatever object it is, I think even if you call it an optical illusion, it's not true that you're seeing some
Well, you wouldn't be
manifestation of
seeing
the sun. You're seeing the sun. It's just the light's being bent in order for you to see.
You
it.
wouldn't
You're
be
not seeing
seeing
it in
the
its
real
actual
sun
position.
because you wouldn't be seeing the real sun, or because if you were, it wouldn't be producing the effect of appearing to touch the ground, right? How do you have something? How do you have something that's supposed to be real appear to do that effect? You need a refraction for that explanation. You need to have that
for it to
optical.
appear to be touching the clouds?
Well, if
Like what you're saying
appear to
is-
touch,
is-
what do you mean
doesn't make
appear to
sense,
touch
man.
the clouds? It's all optical illusions, right? So what do you mean appear to touch the clouds? What are you saying now? Are we? Is that
The fact that it
fucking?
appears to touch the ground is irrelevant.
What do you mean? Is that
Yeah,
irrelevant?
you
It's
don't
not
need
happening.
reflection. And you don't need.
It's not happening.
It's not
So-
happening.
So
Everything
you're
behind
explaining.
something else that's not
You're
happening.
explaining that optical illusion
angry.
and using refraction to do it. That's what you're
Data.
doing. And then you're
What
telling
age
me
are
that
you?
it's not an
What
optical
age are you?
illusion, and then it's down to semantics, or what was the was that the claim?
It appearing to be touching the water or whatever has nothing to do with what's the illusion is. The illusion is that it's supposed
Well, that's an
to be.
illusion.
The illusion is that if you were to make an actual straight line in 3D space from your observer to the sun in our model, it said that the Earth would be intersecting that line, or that line would be intersecting the Earth. And so the fact that you can see it is what is, I guess you would call the illusion, is what you're saying. But that doesn't make it not the sun that you're seeing. You're still seeing the sun.
See, that's the same
So
thing that
here's
happens
the
on
reality.
the flat Earth.
Refraction.
It appears that the sun is going into the ground, but in reality, it's not. You understand?
You
I know you guys
brother,
ask us all about this every fucking
every
day.
object that is
So
in
I want to
front
make
of
sure you guys
another
understand that it's refraction that causes the sunset. Okay?
No, refraction can't cause
That's
obstruction.
how you explain it on your model, dude. You explain the same thing, why it happens, why the appearance of it touching the ground. It's due to refraction. It's the same explanation.
Refraction can't cause obstruction.
When the sun is on the horizon in the heliocentric model, are we seeing it in its actual position, Brenda?
No, you're seeing it 8 minutes late, and if it's
Okay,
close to the
so
horizon,
it's
refracted.
apparent position. Is that correct, Brenda?
That's a different question.
So that's
than
what
does it
happens
cause
when we
obstruction?
see the sunset on the flat Earth. You're seeing it in its apparent position, not its actual position. Understand?
No,
It's irrelevant.
those are
It's
two- hey, hold
irrelevant
up.
to obstruction.
It's
Brandon, that's two
irrelevant.
different questions. What?
Yes.
That is one question is does it cause obstruction? And the other one is
Yes,
its
in
apparent position.
perspective, yes, perspective will cause obstruction because all of
Show
the
me that,
angles of
then.
light. Well,
Show
this
me
is
that.
how light will. This is how
No,
light
show-
works to the eye.
Overlapping.
As Silent Zero
It's
correctly
not how
said,
light works.
show me does not
Again,
mean talk to me about
Overlapping.
it. Show me where.
Yeah.
Show me where.
Let me know when you're done.
Refraction.
Let me know when you're
Show
done.
me where refraction causes obstruction.
Okay,
Are you
here's a little
serious?
tip.
Wait, hold on.
Here's
Yeah, go ahead.
Can I-
Show me.
hold on.
I can do
Data,
that
let
real
me-
easily. Hold
Data.
on.
yeah.
Wait, just for clarification, you can bring up whatever you want, Brandon. I'll just talk about this real quick. So RC, would you consider an inferior mirage refraction phenomenon?
Go ahead and tell me or show me.
Would you?
I'm bringing it up.
Okay, I yeah. Again, first of all, I want to hang you by your own rope. Okay,
Well,
are
that's
you?
fine. If I'm
good.
wrong,
Okay,
hey,
just
I
answer
didn't
the
ask
fucking
you a question.
question.
I said show
Just
me.
shut the fuck up.
Well, why don't you show me and then
Do
we'll
you?
talk.
Okay, Brandon's pulling it up. I'm asking you a question in the meantime.
I don't need any questions while you're showing me something.
Okay. Do you consider an inferior mirage a refraction phenomenon? Yes or no?
Waiting for you to show me.
That's an easy question.
Cool.
Show you.
Loading. I mean, you could answer it while we're waiting for it to load.
Wow.
No, you
I'd like
can't,
him
because
to
it's
show me.
donkey. Ladies
then
and
we'll
gentlemen,
talk.
it's donkey talk.
There we
Donkey
go.
talk with
Have you
RC
ever seen
Mike.
this, RC? It's shout out to Pebble on the Pond, who I talked to over the weekend, and he's doing some exciting stuff. But let me show you this. Are you familiar with this footage? What this is, just for the audience sake,
Go ahead.
is a couple of targets across a relatively flat enough for this purpose surface, concrete floor. Like I think it's 75 feet, something like that. It might be more than that. I can't remember. I've got the details somewhere. And you see these targets. This is what we're looking for.
Yep.
There's one more picture that'll come up. Let me get to that. Okay, see that? That's that, right? There's a light over here. I want you to watch this light. I want you to watch the effects on this, okay? So just imagine in your mind that this is thousands of miles away. And this is the sun as it descends towards the horizon due to perspective, okay? Now, watch what happens when we have a temperature differential that enters the picture. Here, the garage door goes up. Cold air from outside rushes in. Now we've got heat from the inside colliding with cold air from the outside.
Cool.
And the light is obstructed completely for a couple minutes, I think it is.
Okay, cool.
By
Good.
the atmosphere.
I love this example. Thanks, Brandon. Thank you.
There you go.
I appreciate that.
Does that answer your question? Because you asked, show me
No,
refraction
absolutely,
obstructing a light, didn't you? Is that your
Brandon,
question?
absolutely. I appreciate that.
Okay.
So what you showed is that if you put a light approximately an inch off the ground, you can get some air to have obstruction, correct?
Yeah, I mean, if you
can
want to
show
get
you
literal about
other
this is just a
right. What a dick.
conceptual,
You know, Brandon,
small scale.
Yeah,
You know how we
stop
do
being
in
a
the
dick. That is
laboratory when we
exactly
take
what I
like
wanted you to
a fish. I'm answering your question, like a fish tank, and we shoot a laser through it, and then we apply that to like observations that
Oh,
are
yeah.
over 10 miles
Sure.
and say, we understand how
Absolutely.
refraction works. This is the same
Yep, we
concept.
do.
It's actually a bigger
Can I
scale than a fish
can I
tank.
try?
So,
Can
Brandon,
I,
hold up.
RC?
Hold
I
on,
want
let
to
him
ask you a
respond,
question,
Data.
RC.
Hold on,
this,
Data.
Brandon.
Let him respond.
Brandon, I'm glad you showed this because in each example, what we have is something really, really close to a surface, right? Potentially getting obstructed by
Oh, so
something.
now you're moving the goalpost.
No,
Yeah,
Brandon.
now you're
Brandon,
moving the goalpost.
Brandon, I'm not moving any goalposts whatsoever. I'm
What did
actually
you ask us
you
to
said
see?
refraction doesn't obstruct.
Brand,
You
no.
said
What did you ask us to see,
refraction-
RC?
No,
Travis is
what I-
right. Let's remind
refraction
ourselves
doesn't
what you
obstruct.
asked us to see.
What I said, Brandon, was show me when refraction can cause something to appear to be obstructed. And the answer is, yeah, when it's really, really close to a surface of something. So now my question is,
No. You're
so
adding
you-
shit to it.
Like
So
in all observations.
Right,
you
yeah.
said, ask us, show
sociopath.
us refraction obstructing an
what I said,
object.
Brandon.
We have showed you refraction has the
I know,
capacity
Brandon,
to
and
obstruct
that's
an
what I'm trying to
object,
highlight for
haven't
you.
we? Have we not
Can
done
I
that,
try a
RC?
scenario?
Brandon, you 100.
Can I try a scenario? RC,
Okay, thank you. I'm 100% correct. He said,
You 100% did. And what
Yep.
I was highlighting for you is I was hoping you would show an example where something is right off the surface of something else.
Okay, great.
Just
RC,
like this.
RC, great. Okay, great. So would you accept? Hold on. Would you accept 22 feet off the surface of the water? Would you accept that height?
Oh, sure. Yeah. Let's do 22 feet.
yeah, there seems to be some scaling to this. Imagine that. This is what, 75
Yeah.
feet and it's a few inches?
So we can get to like
He's going to show us a
22
few
feet.
miles. I wonder what happens over thousands
Sure.
of miles,
Let's see if we
RC.
can get to a few miles, Brandon.
I mean,
Let's see
we
if
can
get to a
scale
few
things up just like the fish tank. When we scale that up and apply
Sure,
the
Brandon.
refraction to the whole world, we can do the same
Sure.
thing here.
Brandon, I get that. I get
Yeah.
that. Now I'm asking you to do that.
Can I
with
ask RC a scenario here, bud?
couple of dozen miles.
RC, just let's just use this as an example. Just indulge me for a second.
Hey,
you and me are.
but hold up.
You and me.
But
Listen,
before that,
bro.
I
Listen.
wanna ask
Hold on.
Brandon.
You and me are walking in the
Brandon.
desert. Hold on.
Hey, no,
You
hold
and me
up.
are walking in
I
the
don't need
desert.
any
Listen, bro.
hypotheticals. We're talking about real life,
No.
Brandon.
I just want to
You
know.
showed
I
an
want to. Yeah, it's
excellent
real life.
example
It's
here.
real life, but we're just doing
And
a
so my
story. Like we're doing a
question
story,
is,
but it's real life.
You think that we can
Real life
scale this
scenario,
up to
right?
a dozen miles?
Yes.
Okay,
Yes,
so
we
RC,
can.
just indulge me. RC, indulge me for a
Yes,
second.
I
You and me
can.
are.
You think that we can scale this up to a dozen miles? Okay.
I can do it at 20. I can do
You
it
can
at
do
20.
it
Yeah,
at
let's
20.
see it. I think Travis offered to show us something like that.
Okay.
So why don't we give him an
Yeah, go ahead.
opportunity to do that?
Sure. Go ahead.
Okay. All right. Listen, hold on now. Before you string me up, my first response to you was, how would you consider 20 feet? Correct?
I said, sure. Yeah, let's see it.
Okay. So the video that I'm going to post in general is one that I just put out. I don't know what the timestamps are. I don't give a shit if
Okay.
you look at it later. I don't, Brandon doesn't need to show
cool.
it right now, but this is something
Cool.
that I put together, and it's
All right. No problem.
Well, RC, I just wanted to do this scenario with you as just to see how you would think, or your answer. If you and I were walking in the desert, and off in the distance there was another group of people walking in the desert. And by the way, this is a shout out to Travis and that PhD video, the guy there explaining refraction. You and me are out in the desert, and a group of people are ahead of us. But it looks like they're. We were going to write in our journal, and we're looking at what we're observing, and it looks like they're actually drowning in water as they walk away from us.
Okay.
What do you? How would you write that in your journal back, like thousands of years ago? If you were first to look upon a desert and see this refraction and groups of people disappearing into it.
I'm not interested.
What would you
in
just?
your,
What would you write
We're
that?
talking about reality right now. Kosho,
That
what
is
were you
reality.
going to say?
That's a reality that a PhD doctor used.
Go ahead, Kosho.
That's what a PhD doctor used as
Kosho,
as
what
an
were you
example of how refraction hides the bottoms of things, dude.
Cool.
So when I
Yeah,
want to
so
ask
what
you,
were you saying?
when I want to ask you a question, how would you think about that? I wanted to know your logical reasoning of what you would see. So your argument is that this particular effect cannot block the bottom of objects. Is that correct?
No, my point is that My point is that you trying to say the sun, which is, according to all flat Earth accounts, a couple dozen miles above us, right, is somehow blocked by
All flat Earth
refractive
accounts,
effects.
RC?
Most
Couple
flat
dozen
Earth
miles.
accounts. Yeah, sure. Like I've heard anywhere from 30 to
Just
3,000.
make shit up. Go ahead. This is story time hour. Go ahead. Tell us the story.
Brandon, I've heard anywhere from 30 to 3,000. Is that fair?
I've heard that too. So go ahead.
Okay.
Continue.
Cool beans. So my question is, how do we get something 3,000 miles above us being obstructed halfway, okay, by the ground? And so what you guys show me are things like, I don't know, 24 feet, a couple of inches, half an inch above the surface. And I say, okay, cool beans. Okay, so you get these really extenuating circumstances with a couple of dozen feet, couple inches. Now, do you think that works with anywhere from 30 to 3,000 miles like that?
Yeah, I do. I think it's the same principle.
That seems like a really
distances.
weird leap
Yep.
to me.
I don't think
Seems
it
like
is
a
at
really
all.
weird
No,
leap
it's,
to me.
it's,
With something
it's
as bright as
absolutely
the sun.
practical.
Yeah,
Absolutely
makes
practical.
perfect sense.
Okay. Yeah, that seems like a big leap to me with something as bright as the sun. Kosho, what were you gonna say?
Your inability to comprehend these simple matters
Well, it's
is
not that
not
I
our
don't
problem.
Just
comprehend it,
incredulity.
is that
Uh,
the
nuh-uh,
analogy?
nuh-uh.
No, hold up. The analogy doesn't seem to hold very well, especially where
Really?
you don't have anything.
You say something as bright as the sun, but can't we look at the sun
wait.
with our own two eyes on the horizon?
Kosho,
We can see the sun with
Kosho,
our
I
own
meant
two
to
eyes.
hear what you were going to say too.
The simple idea and demonstration of refraction hiding the bottom of things, which it can be demonstrated, is only applicable in short distances, RC, in your mind, and it's not applicable to
That's
long
not what
distances.
I said in distances above a surface, given things that probably aren't dozens of miles
shorter
long.
or longer, right? Essentially your parameters are shorter or longer. Obviously the higher I go, the farther the horizon extends outward from me, right?
So Data, would you agree that refraction has various limits that we can impose upon things?
May I ask you something?
So all wavelengths of light have different refraction short
Data,
lengths.
answer my question
So-
before you get off on a tangent. Does refraction have limits as to what it can make things do or not?
May I ask?
What do you mean has it do? Your argument is that refraction can't hide the bottom of objects.
That's not my argument. We're specifically talking about.
I'm sorry, that's not your argument? You don't stand to the position that refraction can hide the bottom of objects?
Listen so that you can understand very carefully. The argument was that refraction can hide the bottom of the freaking sun. I said, nah, doesn't seem very plausible.
No, the
You
whole
said,
sun.
Check it out. I can
Brandon,
make
may I say
things,
something?
hold up. I can make things disappear an inch off of the ground at 22 feet off the ground. I say, okay, cool beans. It seems like there's a leap right here between
RC,
the
here's a
sun,
leap.
which is anywhere from 30 to 3,000 miles above us.
And you already said
and it
that
being-
in your model, the refraction is making the sun appear when it's already behind something. And you have the gall to
Okay,
sit
cool
here
beans.
and say that our model is impractical?
Yes, I'm going to say that. So, Kosho, what were you going to say?
Based on what? Your own incredulity?
No,
I just want to point out something, Maisty. You say that
Can I
sun is
get
something
give me a
that
second?
bright.
Can
Hold on,
Kosho say what he was going to say?
something that bright, it could not be hide. I just want to
No, I
remind you
said
that
something
when
that
the
bright
sun,
can be cut off halfway using refraction.
just want to remind you that when the sun is on the horizon level, it's not that bright. Okay.
Okay.
You can
when the
actually
sun-
see it
when the sun-
with your naked eyes.
Okay, my point is that the sun being cut off halfway using something like refractive effects, if it's purported to be anywhere from 30 to 3,000 miles above the surface, doesn't seem something that is practically demonstrable.
Oh, I don't think it's a refraction. I think the limit of your angle is what is causing that.
So it cuts off buildings. It
But
cuts
that's-
off half of a building. What's the problem?
Oh, it cuts off half of a building.
Sure.
That's the point. Is it does RC trust me.
Optical illusion, foreshortening
When I
effect,
saw-
RC, look in general.
When I saw this,
Look in general for
this
some lovely,
observation,
lovely observation.
When I saw this observation, one thing I noticed that the claim that refraction can cause things to be obstructed was true in only the sense that this is actually you're observing mirroring in this. So it's literally the image itself is being mirrored and obstructing the other object, which is of course what mirroring is, which makes sense in refraction. But there's not another kind of refraction that causes the same effect. It's literally just the fact that the image, part of the picture is being duplicated. And
where is in Pebble on the Pond's footage? Where exactly is the mirroring of the light when it's hidden? I don't see it mirrored here.
No, it's not the mirroring of the light. The thing that is blocking it supposedly is a mirror.
Imagine this is the sky behind it. So this is going to mirror the sky, and and it's going to look like the sun goes down behind it.
No, and that's my point. Whatever the reasoning is, and Kosher's 100% correct in this.
No,
my
he's
point
not.
is that every time you try to demonstrate this, you're using really, really small or really, really close to the surface objects, right? Compared to what you're trying to say.
It's the same principle.
Cool. And if you think that it's the same principle, then show it to me with
Well,
this
we're
type
going to
of
have to
pressure
throw
gradient
out
that
some
we're
other
looking at.
stuff if we're going to go by this principle, like your understanding of refraction and how light moves through the atmosphere at distance. We're going to have to throw that out. Is that okay?
Why would you throw that out if you're literally trying to tell me
that's all laboratory
that it's happening
proven.
Hold up. If you're literally trying to tell me that this is something that happens over the course of thousands of miles with something that's either dozens to thousands of miles in the air, then it would seem that, you need to show that this thing can scale over thousands of miles.
Okay, when have you shown that refraction scales over thousands of miles, like in the
Brandon, you're confused.
apparent versus actual sun? When have you shown that?
Brandon,
you're making that claim.
You're confused as to
I'm not
who's
confused.
making
Just
the
answer
claim
my
right now.
question. Answer my question.
So Brandon, you're claiming that this can happen with the sun.
So
I said,
here's the thing.
there's
No,
practical demonstration of this
RC.
happening.
Just save your sophistry for a minute. You
Not
do
a
things all the
sophistry,
time where you take small scale stuff and apply it to very long distances, such as with refraction. It's a perfect example because you'll sit here and tell me that refraction is causing me to see the sun when it's actually physically blocked.
Okay. And we don't have any problem with that in our model because you're looking through the thickest parts of the atmosphere. Now you're telling me.
Now we can apply smaller things to longer distances because you don't have a problem with it in your model? Was that your justification?
And now what? Yeah, there's not a problem at all with it in the model.
There's no problem in our model with what we're saying.
That you're trying to say now, okay, you can actually do this over dozens of miles, right? In your model where the sun is staying at essentially the same height, right? And the angle from you is only appearing to change, but not actually changing, apparently.
Huh?
Wait, what? No. I don't think that's correct.
Oh, you don't think that's correct?
Can you say that again? I want to make sure that I didn't misunderstand you. Can you say that again?
Yeah. So
even Brandon reacted to it.
Yeah. So is the sun actually changing its angle to where I'm standing, or is it just appearing to?
Wow, who knows what it's doing that far away? It could change. It could change its angle.
Sure. So it could appear to change angle just like it does in your model.
Okay, cool. So if you think that it's changing angle, how do you know that? And then if you do know that, then how do you know that it's the refractive effects that are causing our
How do you
angle
know
to be refracted in some
How do you
type of
know
way?
it? How do you know it, RC?
Oh, well, hold up, Brandon. You just go about making a bunch of claims, and then I ask you how you know, and then you say, well, how do you know?
Yeah, I'm pointing out your hypocrisy.
No, Brandon, that is not hypocrisy. It's me actually interrogating your
No. You haven't interrogated your own claims. You're sitting here making claims and then criticizing
Who made a claim,
the very standards that you're holding yourself to.
Okay, Brandon. So if you think that I'm making claims by asking you to back up what you're claiming, that refraction causes the sun to be cut off halfway, then you're completely backwards.
I just showed you a small scale demonstration. What are you talking about?
And you said that it's a small scale demonstration with something inches off of a surface.
Yeah, that's right. That's what a small scale demonstration is.
Could you even do that? Could you do that exact demonstration even 100 feet off the surface with the camera?
Okay, listen.
What about
if
you're an the object 100 feet off the surface?
Hold on, Gleam.
Anybody?
Again, okay. Don't call me buddy, okay?
Nobody can do that.
No,
it wouldn't change. It wouldn't change the principles, buddy. It wouldn't change the effect.
Do that.
What the hell, Data? Just let me. Okay, look, RC. If you're interested in seeking for these realities.
I'm
Okay,
interested.
my video that I put in the chat, I tagged you in it. If you go to minute 12:40, okay, there's a text there. Okay, so you cannot see my friend Derek at ground level, which is about 10 to 12 feet off the water. He has to climb onto a higher platform, which is a replica cannon in front of the lighthouse. Still can't see the light, so then he holds the light over his head and tries to flash the movie, and then we can see it. Okay, so we've got 12 feet off the water. The cannon is about 4 feet high, and then he's 5 foot, so that's 9, and so say just 20 feet. Okay, because he raises his arms over his head, 21 feet. Then
How far
you
is
can
the
see
lighthouse?
5.85 miles.
So we've got 6 miles with 12 feet. We've got 75 feet with 2 or 3 inches. It does seem to extrapolate.
Okay, cool. Does it extrapolate at scale? Do you get the same amount of refraction at 100 feet or at 15 feet as you do at 1 inch?
Well, you got to take
Okay, look.
perspective into account, which we're going to disagree with.
No, don't say
So it
don't
does.
say
So
look.
it does. So it does.
I don't
or it
know. I
doesn't
don't know if
scale?
it does. I've never done the mathematics,
Okay.
but
So Brandon, here's the reality. It doesn't scale once you
you
go
don't
to
know.
100 feet.
You're
I do
just
know.
learning about this idea,
I do. No,
and
Brandon,
you're sitting here
I
saying,
do know, and here's the reason
"No,
I
you
do
don't.
know, and I can
No, you
and
don't."
I can show you how I know. So
Okay, hold on. Again, no, you don't know what you're
so here we
talking
go.
about. Let me
At
jump in just real
5,000
quick.
feet, when I'm looking out of my
Go
airplane
ahead, Travis.
window.
Go ahead, Travis.
So
Okay, hold on, RC. It'll just be real quick. Okay, so I've also photographed the Anacapa Island. Okay, and roughly I'm at 10 feet, 12 feet, even maybe say 15 feet off the ground, depending on, or off the shore. Okay, now Anacapa is 220 some odd feet as a landmass. And then you have a 50-foot lighthouse on top. So we got 272 feet at the point of light. Okay? Now, I have various sizes of this lighthouse where you can see massive land underneath it, and the lighthouse is very far off the water. I've got the images where I can show you that the lighthouse is just barely off the water. So that shows you that the refraction at that distance compresses the image so much that it brings the lighthouse almost down to water level.
Okay.
Where did that 220 feet go? I'm at the same location, right? So again,
Cool.
yes.
What's your
again,
height? What's your height above the water?
12 feet. I'll give you 12 feet.
Okay, cool.
So we've got something that is 220 feet high, and you're missing mass amounts of that land underneath.
Cool. Okay. Now, my question was, and my ask was, can you put your observation at 100 feet even, and try to look at something 100 feet tall away and show this type of refraction happening?
How far away?
Yeah.
Oh, however far you want.
Yes.
Okay, can you show me that?
No.
'Cause
Well,
here,
why
I'll
wouldn't
tell
you
you
though?
my I'll
So
tell you
you're
my- I'll
100.
tell you
You're
my
100
beef
feet
with this.
tall. You're looking down
Brandon.
at the horizon.
Yeah.
At something at 100
I'll tell you
feet,
my
I'll put
beef
it
with
2,000 miles away.
Yeah,
We got a
I'll
lot
tell
of
you my-
fucking demonstrations.
hold on.
Hold on a second. We got a
I'll tell
lot
you
of
my-
fucking
I'll tell you my beef with
demonstrations.
this is that people are always anywhere from 1 to 10 feet off of the water, looking at something that might be
play
quite
me your
a,
little
quite a bit
fiddle
away.
later. Come on, man.
No, but
we
really,
got a
some
lot of
people are like 1 to 10 feet off the water.
You know
1 to
how
20
many
feet off
claims
the
you
water.
make about how light works over distance and shit that's all
Yeah,
based
sure.
on
And I'm
shooting a
asking you to
fucking laser through a
substantiate
fish
yours.
tank? Give me a fucking
Yeah,
break.
Brandon. Yeah, Brandon. And
we
so
got a-
I'm
we got a
asking
lot
you
of-
to substantiate
we
your
got a
claim
professional troll
that
right
you can
here.
use refraction to cut the sun,
Just
which
stop,
according to you
RC.
is anywhere from
Just stop.
dozens to thousands of miles away.
First, this all
We got
started
a
with
lot
you
of-
asking us to show you refraction obstructing something. We showed it to you, and now you just keep jumping from one thing to another. We showed you a higher
I've been on the
we
same
showed
point
you
the
a
entire
higher
time.
something bigger being
Brandon, I've
blocked.
been on
Now you're
point the
jumping
entire
to
time.
well,
Great.
what if you're
Which one?
higher and looking higher, and the other object's higher, and this and that,
Yep.
and this and
No,
that.
Brandon, it's been one
Just
thing
a
the
new
whole
hoop
time,
after
which
new
is,
hoop.
can refraction cut the middle of the sun off? That's been the whole thing the whole time.
Oh well, that's
Yeah,
easy.
but then you
yeah.
said
Here,
go
let
up.
me show you that. Gleam posted that. I mean, that's simple. We've caught that phenomenon many times.
We've got refraction blocking out a whole light. Why couldn't it just block the bottom of it?
Cool.
Here.
So
You don't even need
how
this.
do you
They
know
wouldn't
that-
even call this a sunset necessarily, but here it is.
Okay, cool.
Here's what you asked
And
for.
would you say that the atmosphere is blocking off that sun?
Yes, I would.
Oh, really? Okay, because it looks to me like that water is blocking the sun.
The water ramps up there? Wow, that's a fucking amazing ramp. Look at the shallowness of the water and just kind of look at it with your eyes down here, right?
Yeah, sure. I'm
and then
saying that the
look
water
at this
is
up
blocking half
here.
of that
So
sun.
does it jump up there, or how does that work? This definitely
No,
is an
that-
atmospheric
what's
phenomenon
That
here.
would be just to be like a layer of air.
You
that
don't know
the
what
sun is
the
just-
fuck you're talking about.
So are you talking about why the top part of the sun looks distorted like that? Yeah, because of a layer of air. I'm asking you, why is the bottom half of that sun cut off? That's what I'm asking you about.
That's what I'm telling you.
You're saying it's
There's
water,
an
but then
atmosphere.
it's completely different than the water below.
What is cutting off the bottom half of that
The
sun?
fucking atmosphere for the third time.
All right, well, why does the water seem to be in front of it then?
Do you see the shallowness of the water? Look at the water and watch as it goes out towards here. And now,
Oh, I
whoa,
see
it
it.
jumps up here and you can see this different background here. See, this is the atmosphere.
Okay. And why is the water seeming to cut off half of that sun there?
Here, let me have
What
a
the
little.
fuck You didn't say are the you water talking is the about?
atmosphere, bro.
Yeah. Why does
No,
it
my
appear as
point
if
is
there's
that
an outline
the water
all
just
around it?
cutting it out.
Because the floor is appearing to rise up, and that limits your view. There we go. There's your
Hey,
answer.
RC, if it's water that's blocking it, then are you saying that the waters above are different than the waters below?
For the demonstrations, it's just as simple as: do you have any demonstrations that don't involve mirroring? The small scale thing with the mirroring, that of course it's gonna block it. This is a obviously refracted where you have what do you call that? We have
It's called a Wegner's blank strip. If you're lost for words, there, mate.
no. Well, I mean the point is that it's distorted due to refraction. There's
Taking the
refraction.
school, Blake.
There's refraction that happens that is not distorted. A lot of sunsets happen that are not distorted. There is no mirroring in a lot of sunsets.
He didn't learn.
So in those examples,
There is always refraction, Kosho, no?
yeah, there's always refraction. The refraction is not always distorted. Yeah,
that's
Well, in your model, when the sun is behind the earth and it's refracted up, is it always distorted?
So here's a good example.
Oh,
what Kosho's
okay. So
talking
what's
about.
the difference then, Kosho? It looks like we have the same phenomena that we're talking about, and RC doesn't want you to answer the question for some reason.
yeah.
But-
Refraction can cause things to be out of position, which is what it does every day to the sun.
Oh,
It
okay,
also
cool.
it also can cause distortions, which it does not do every day to the sun.
Hold on a second.
There we go. It looks
Travis.
like the models are pretty much the
guys, hold
same
on.
in that respect then, huh?
No, they're not at all. Because here's the example.
We just
of I'm
went through
showing
it.
you an undistorted sun being cut off halfway by a very clear and crisp water. But here you are saying,
Yeah,
"Oh,
just explain that.
No,
I just explained
No.
that. Didn't you hear it?
that was not clear and crisp. No.
Yeah, it is.
Zoom into that.
Okay, just real quick. You guys are gonna, if you zoom in on that photograph that Brandon originally showed, you're gonna see a dark band above the water. Okay, you are not looking at the sun. That is not the sun. Okay, that is a reflection off the band, off the medium. I know that you're not going to
All right,
accept
here you
that,
go.
but
here's
that,
another one.
Crispy.
Here's another one. Where-
That's
I just
exactly what it
put
is.
this one up. Hey, Brandon, put this next one up here.
In the globe
Clear
model as
and
well.
crisp image. Where did the other?
listen.
where'd
All
the
you're
other three
doing,
quarters of that sun go?
listen. That's not the fucking sun, you dope.
Okay,
That's
so
not
where
the
the other
sun?
3/4 of the sun?
No, that's not the sun.
Oh,
it's
it's
not
not.
even the sun in your fucking model. You
Yes, it is.
Hey,
cuss word.
Brandon,
It's an
Brandon,
illusion.
No, it's
can you
not.
post the next, or can you project the next thing that I just showed?
This? Is it on my screen?
No, the next photo that I just posted.
Well, I'll answer
at
your question about this one.
at
It's refraction.
Okay, cool.
Yeah.
That's a weird thing because I don't see any other distortion happening here. But now you
Well,
want
that's
to say
okay. You don't
refraction.
always see distortion with refraction, as you guys have been telling us with the globe model.
All right, Brandon. So where's the other 3/4 of this sun then?
It's refracted, so you can't see it.
Okay, so why don't you see this type of distortion like we saw in your example where you said,
You don't
"Hey,
always
check
see
it out." it's the
distortion
air
like
that's
that with
blocking
the
it."
refraction. There's lots of variables between you and the sun.
Kosho's
Just like on your model where we don't, how
bottom
come
up.
we don't see distortion on your model when the sun is blocked
Because
and we're seeing the apparent sun?
why don't you see that
We
type of thing?
sometimes see distortion and sometimes don't on both models, it looks like, right?
Well, refraction sometimes will include a distortion, and sometimes it does not include distortion.
Well, there we go. There's your answer. You answered it yourself.
It's always there.
Yeah, but in your example, for why it's being obstructed, it would need it would need to have some of the distortion, like mirroring, for example.
No, it
need to have
wouldn't.
mirroring.
No,
we don't need it on your model.
There's no other cause for obstructing it then.
We don't need it on your model, and it's happening.
No, no other cause you know of, Kosho.
Yo, Kosho, that's a weird gift.
Right.
Do you know? Do you know of all the causes that can happen?
So what kind of refraction is that?
I've just said it 2 minutes ago.
Kango 24, $5. What's up, Kango? Talk about delusional, 3 exclamation points. I thought we could use our senses. Isn't flat Earth about what we observe? Yeah, we're talking about what we observe, aren't we, Kango? Like when I just showed that the atmosphere can block a light, or we're looking at these sunsets. Those are observations, right? That's what we're talking about. And you know what none of these have in them? Curvature. I don't see any curvature here. I don't see any Earth spin.
And close.
No one
But
said
the glare,
the opposite.
Yeah.
if the glare was
said
actually
otherwise.
removed, it would be smaller. Would you agree?
No, not necessarily. It depends on how much glare there is.
Hold-
So the proof, the point
So
is,
you're saying
on
you can
flat
remove
Earth-
glare, but the sun will not become
You don't know
smaller
anything
in
about
size.
the sun.
It won't be its actual size, like an actual apparent size.
Well,
Is that what
it
you're
is
saying,
smaller.
Brenda?
It is smaller than the glare.
Well, it doesn't look like it in this GIF.
Yeah, it does.
All right.
So when did you do a flat Earth
Forgive me,
model,
I forgot who
Brenda?
I was talking to.
Right, because
Kosho, I
the
think it was.
orange, the reddish orange part is the glare.
Yeah. When
And
did you
that
last
gets
do a flat Earth
reduced.
model,
That gets reduced,
Brenda?
doesn't it? So that shows that it's far away, because if it was close, it would reduce in angular size, and the sun never does.
That's not what it shows, but when you speak, you are showing something.
You just literally
Right, so
said it gets smaller, but it
No.
doesn't change in angular size. It just
That's
loses
right.
its glare, yeah.
It loses the glare. The glare
And then
isn't
it
part of the
changes
sun.
shape as well, doesn't it? Because it looks a
The
bit
glare
like
isn't part of the
rugby
Is
ball.
glare part of the sun, Gleam? Is glare part of the sun?
Well, yeah.
Yes, it
No,
is.
it's not. No, it's
Of course
not.
it would be. It would be part of the
No,
sun.
no, it's part of your eye. It's a part of your visual apparatus.
Is light part of the sun?
Yes.
So glare is
Exactly.
produced in your eye, not in the world out there.
It's
That's not
you're
true.
fucking,
That's
you're
not true at
fucking
all.
insane.
God.
But anyway,
You are absolutely
Glare is produced in the
certifiable.
atmosphere. Genius.
Can I ask something, if I may? If say you got about 5 miles and a distance away, and there's a mountain that's probably about, say, roughly 1,000 feet. Are you tall enough to see over that mountain?
What's more?
Kango 24, $5. Why we don't see airplanes get cut in half as they fly away from us? You can't see an airplane at thousands of miles away. It's not a huge fucking glowing light ball up in the sky. That would be the first things I could think of. No, makes sense to me. I think I actually have seen a plane go behind the horizon and appear to be partially obstructed. I think that's just due down to perspective because of how close it is to the ground. So I don't know, Kango. As usual, I mean, tough stuff there.
Altitude, if you will, if I will.
That's what I'm saying, though.
Why you can see the sunset again?
If you increase your altitude and you're above that mountain, even though the mountain was 1,200 feet, wouldn't matter how far away it is or the sun is, it would never obstruct the sun, which is obviously higher than 1,200 feet.
It should never.
How do you know?
Because that's how perspective works.
Nope.
Yes,
Which you don't understand, Queen.
How do you know?
Objects that are below
How would you
your
know,
eye line,
Kosho? Sorry,
because I
Kosho. How
understand
would you know?
perspective. I'm about to explain it to you. Objects that are below your eye line or eye level, or the height of your eye when looking horizontal, objects that are below that are never going to obstruct anything that's above that line from your vision. It's impossible due to perspective alone.
So
Other factors like the Earth being spherical and curved might come into play, but perspective alone, that'll never occur.
False. Show me the experimental evidence over distance that shows us that.
Kosho, you're telling me.
I'll show you.
So you're
I'll
telling
show
me.
you straight
So
away.
you're telling me if you're looking over Lake Michigan, right? You're looking over Lake Michigan, and the sun is going over Chicago, right? And due to your elevation, 6-foot observer, those buildings and all that stuff, anything wouldn't block it because it's getting further from the town itself.
Yeah, that's an irrelevant observation because what I just said was something below your eye level will never obstruct something above it. In your example, both objects were above your eye level, so that rule does not apply there.
The sun.
Okay, that is obfuscation. Who the fuck is saying something below your eye level will block something above it? Who the fuck said that?
Right.
Somebody who was talking about being up in a mountain.
No one.
Yes,
one
he just
said
described
that.
He just described
No
that.
By the way,
No.
no, wait, hold on,
No.
Travis. I'll say
No.
that. I'll say that. I'll say that.
I'll back that.
Yep, I think that can happen.
Well, due to perspective,
How is that possible?
Yeah, I think that can happen due to perspective. I do.
Definitely. Topography, topography. Most things in the world are much larger than humans.
If you're above one of the things, you're above one of the things, right? And you're talking only about perspective, and then another thing is above you. The thing that's below you is not going to obstruct the thing that's above you, no matter how far either of them are.
You want me to tell you how? Refraction.
Gravity.
No, could legit happen with refraction.
A lot of shit happens with refraction. No, I'm not.
You're just trolling at this point.
Why?
We would acknowledge that a number of things
observations on Earth.
I'm making deductions based on the observations, and then I'm making predictions, and I'm looking at the observations, and I'm seeing that they line up with my predictions, which supports my hypothesis, just like you guys do. I learned from you guys.
Well,
Science.
that's fine.
Fucking science, bro.
You'll be listening.
Science.
I said due purely to perspective. You can include other things, and like the Earth being curved or refraction, and cause different observations. But when talking purely about perspective, this is an impossibility. Perspective says that does not happen due to perspective.
Hey, Kosho, what is curve?
I was gonna say, can I show you?
Can I look
Yeah,
at?
what
Can
is
I look
curve?
down at something
It's a ra-
that is higher
it's
up
a-
than me?
It's
Is
a
my question.
non-linear rate of change.
Yeah.
What about change in elevation?
Curve is a non-linear rate of change.
Let's make it real simple. Change in
Deviation
elevation.
from a straight line.
That's a real simple.
Brandon,
I agree with that.
Brandon, I got a question for you. Can I look down at something that's higher up than me?
Down visually,
Sure.
yeah.
Down visually?
Yeah.
Okay.
If I drew a Euclidean line from me to the physical line from me to the object,
What are
it
you
would
talking
be,
about? A reflection?
it would be lower than the
You put
object.
a mirror on the floor, yeah, you can see something above you.
You
What
put a
about-
beer on the what?
Yeah, but that's not looking
Mirror
down.
on the floor.
A mirror.
Oh, that he said beer. I was so confused.
Hey, Chief Squatting Dog,
Talking
you want to
about
know how I
beers,
know?
How?
Because I observed it in the world. And it must be true since
same,
the
where?
Earth's flat.
Oh, how so?
Well, see, I look out in the world, and I look at great distances, and I see things that are higher than me, and they're lower than my eye level optically. And so
What's
I
a- what's a
deduce
great
that
distance to you?
since the Earth is flat, that must be how perspective works.
What's a great distance to you?
Oh, don't. Brandon's being lazy, kind of.
Do you have any experimental evidence that falsifies
He's
my
basically being a
hypothesis?
little bitch.
Do you have any experimental evidence that falsifies that?
We have measurements that falsifies it.
Because I've asked it
What's
for
a
it
great
before, and you know
distance
what
to
the
this
answer
guy?
is? You know what your answer is? It's impossible because of Earth curve.
No.
Isn't that a knee slapper?
I'm
No.
not sure why Ellen keeps getting muted. He didn't even fucking light up.
We know how refraction works.
Deserves it.
And in order to do what you say it does,
Right.
the world
We know
needs
how
to be
this
upside
works. We know
down.
the Earth's a globe. We know how perspective works. We know how
We
refraction
know-
works. Blah, 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 blah. It's all circular fucking bullshit.
Sorry, we know anything.
What I want to see is the experimental evidence that optics works the way you say it does over long distances, not assuming the curvature that you're trying to prove is there. It's very simple. But
Yeah.
you say you can't do it
Bro,
because there's
can you hear
curvature.
me? Can anyone hear me?
No,
Mic
we're
check.
talking about your
Yes, we can.
observation.
Okay, what's a long distance to? What's a great
His
vast
observation is you measure your own elevation. You measure the elevation of whatever big thing is in the distance. If it's, it could be whatever distance, as long as it's going to be below your eye level, because of perspective on a flat Earth, that's what we see. That's what we observe.
Oh, he already got
Yeah.
scared of my
That's,
question.
Falsify it.
What's a
circular
great
reasoning.
distance to?
That's circular
What's a
reasoning.
great vast
That's what
distance
you
to?
guys give me. Like I said, I
Pick a
learned how to
number.
do science from you guys.
Pick a number. What's a
I
gra-
made
what's a-
You have
predictions.
measurements. You
Hey,
measured
listen,
your height. You
I'll
measured
say
the
it
building's
again.
height. It's taller. It's below the eye level due to perspective on a flat Earth. What's wrong?
Yeah. I
Whoa,
made
you guys are
predictions on how
terrified
things
answer,
would
aren't
look
you?
based on my flat Earth model. The reality matches it. Therefore, my model is validated, validating my hypothesis. So I have more confidence
What?
in it, right?
Let's
How,
see if you
how's
have.
it so
Let's
hard
see
to
if
get
you're
this
having a good faith
answer?
conversation.
What's a vast distance to? Why can't I get
Well,
it? Where's a number?
5 miles.
Give me a number.
Give me some experimental evidence over 5 miles.
5 miles is a vast distance to you. You know the surface of the Earth is 198 million square
No,
miles.
I didn't know that.
The fuck is 5 miles, bro?
You're comparing a
Come
straight
on.
line distance to a square fucking
Oh, weak.
surface value. It's
Gypsy,
so dumb.
If 5 miles is so short a distance, then it should be easy for you to provide measurements for greater than that distance, right?
Gypsy's about to provide some mountain pictures, probably.
No, I'm just picking up milk right now. I'll be back in like 5 minutes. Got to get milk and then I'll be at home. All those pictures are on my computer. I'm on my phone right now. But no, for vast distances, at 198 million square miles, even your 500-mile photographs or 620, whatever that other photograph is from being on top of a mountaintop, like, dude, that's nothing. That's
Dude.
dust, and you're gonna
So it should be
determine
easy for
the
you.
rest of-
Yeah. What
you're
is your
gonna
argument
determine
here?
The shape of what you're on.
He's
off of
taking
a
you too
speck of
seriously.
dust.
No, he
I
should
know,
take
I
me
know.
seriously.
Jeez.
I'm applying how you guys told me science works, and you're acting
Right.
like
Look,
I'm
you're
joking
back in
around.
5 minutes.
We're gonna test how if you're having a good faith or a bad faith conversation. Have you made a prediction for the for that picture by Blackpool? Chike's
Yeah, I'll release
angle?
it soon. Yeah.
Okay, awesome.
It's different than what you told me yesterday.
No, it should be about the same. I've just got to double check.
Can you articulate where you expect the level line to be,
The
Yes,
level
that's
line.
what he has to do.
or the crosshair? You want to? We can do that. Crosshair.
Oh,
It's
no,
gonna be
we'll talk
above
about that
sea.
when I release my prediction. We don't need to talk about that now.
It's pretty
Yeah, I'd
simple,
like
though,
a
isn't it?
visual as well.
When
So
you
Yeah.
It's going to
2
be above
degrees
main
bending
sea
down.
level. You're aware of that, right? You're going to be above main sea level.
Yeah, I think
Elevation
Brandon's got
change.
the parameters. 1,100 feet, give or take, observer height.
I've
looking
got
over
the exact
Blackpool Tower, looking
location.
at mountains.
Yeah, I'm fine. I've got everything I need. Don't worry about it.
This would be a fun little game. Done. Where would you put the crosshair?
Above main sea level, because you're above main sea level.
Sure. What about let's say compared to Blackpool Tower, or let's say the mountains in the back that are about 1,700 feet?
No, we don't.
Where would you
expect
put
to see
them?
them?
Where would the crosshair be?
1,700 feet.
Where would the crosshair be in relation to those as well?
What camera are you going to use?
So you develop your vertical, you establish a horizontal or a perpendicular from that, and then you place your crosshair in the middle of that. Where is that crosshair going to be in
Great.
relation to the mountains in the distance?
Well, first, I'm not going to presuppose. I like to see this done first.
Chikey provides a
I don't
picture
like
all the
that.
time.
I don't
You
like that.
provided it for a little bit too.
That picture's
like
on
the
a tilt, though. This is going to be completely different to what the dumpy shows.
No, of course, it's going to be the actual picture in frame is going to be different than what is provided. But that's where the prediction part comes in.
So we predict on something that we know is going to be different, and then you get a big old laugh because everyone's going to be wrong.
Right. Well, here's the
Well
thing,
done.
Gleam. I mean, what he's doing right now is odd because a couple minutes ago he was implying that I was making a bad faith argument when I was talking about my predictions. I don't understand. I'm very confused.
No, you are. You're taking the same tone and the same approach that I
You're
take
telling me to
when
make
I'm having bad faith.
predictions, and we're going to compare them against what we see, and that'll validate my model that I used to make the prediction, right, Biodual?
No, I know, but what I was talking about earlier, when you were talking about the vast distances and then your circular reasoning, and then saying you've learned it all from us, that was bad faith.
Yeah. No, that is true. That's
Well,
how you
that's a
guys do
problem.
science. That's what you tell me all the time.
No, never mind.
hyperbole.
Listen, whatever prediction you do, there can be two outcomes. A, you're wrong, and your model is obviously isn't right. Or you're right, and you need to use the model you used to predict this picture to predict everything else.
Oh.
Including sunsets. Yes. You can't use two models for two different models for the
You
same.
can't? Because you use refractive
not?
model for your sunsets.
Always.
As we've gone over
Always.
multiple times on this show, you don't use the same model for estimating things in the distance as you do for where the sun should be when it's refracted and behind the Earth curve, do you?
I'm sure there's a terrestrial horizon and an
we are asking
astronomical
about
one.
where the sun is, where the
They
mountain
even have
is.
different horizons. Huh.
What?
Go ahead, answer, Chucky. I cut you off.
What are you talking about?
Well, I kind of let me rewind it back. Bio, do I actually predict that you guys are not going to pay attention to the location of the sun?
Probably not. To
Yep.
be 100% honest, probably not. We're probably going to pay attention to where the crosshair is in relation to the objects behind it.
So you don't think the sun does? You don't think the location of the sun does not matter at all?
Listen. This is United Kingdom. I don't know if there's sun there at all.
Yep, it's
We don't
blazing at the
expect-
moment. We're having our hottest
Bunch
time.
of clouds.
Yeah, sure.
No,
No,
I'm being
I mean,
serious.
it
It's boiling
in
up,
the
blue
most
skies
pedantic,
where I am.
in the most pedantic way, Don. Yes, if the sun is out, if it's cloudy, if there's thunderstorms, if it's hazy, rainy, all these things, yes, there are effects. What is the most important part is where the crosshair placement is when we know that it's perpendicular to vertical, and then in relation to the objects in the back. That's the most important part.
Perpendicular to vertical. Yep. All right. Hey, you guys. Really appreciate you being on the panel tonight. I'm going to close down the YouTube show. I will be recording afterwards. Recording will probably go all night. Anybody that didn't get a chance to speak much and wanted to say something during the show, I'll give you an opportunity now if you want to just go ahead and speak up.
Did
I'd
you
like
guys
to say something, Brandon.
Did y'all see that new video? The new video by NASA?
I don't know who was first. We'll go with Essie and then go over to Bob. Go ahead, Essie.
Thanks, Brandon. I'd like to say a straight line is a straight line, and a curved line is a curved line. Very simple. A straight line never curves. Thank you, Brandon.
Wait. Hold on. Let me write it down. Can we
No,
repeat it?
Chucky. Yeah, you can reply it back. It's on the on the recording. Go ahead, Bob.
And
Thank you,
Brandon,
Essie. Hold on. I'll go to you next.
Did you guys see? I think it's a new video by NASA about going to the moon.
Really?
Yeah. Now several
William
years
Shatner.
back.
It was narrated by William Shatner.
I don't know. No, I think this was a lady. Well,
Yeah.
I don't know. Maybe it was multiple people that narrated it. But like several years back, they did one, and I don't know if you guys remember that one or saw that one, but that one was one of those. It was like strike up the piano chords, and we're going back. We're going back. We're going back. Just flipping through the people or whatever, talking about how we're going back. Okay, that was several years ago or whatever. And now they're
2024.
And now
Never
they've
about-
released another one that's very similar but a little bit different. talking about how we're going to the moon first, and then basically it's explaining why the moon. That's what the video is apparently about, is why the moon. Why are we going to the moon? What's it's going to enable us to do? Apparently there's all kinds of science and things we're going to discover on the moon. Like, I guess, I don't know when they realize that, but it seems like we've been told repeatedly that there's really no good reason to go back to the moon. It's a waste of time. And now they're saying there's a whole bunch of stuff we're going to discover when we get there. And then we're also going to be able to use that to go to Mars and other places.
Wait, your problem is being open about how
By the way,
they want to do
I
it.
think they even use the phrase something along the lines of deep space outposts or something like that. But we can talk about it tomorrow whenever, after you guys watch it.
Somebody was
Sounds
watching
good, Bob.
Jose's today.
Go ahead, Earth is Life. Thank you, Bob.
No, I just wanted to say, if anybody, well, this is just the SE. SE, I want you to go and look up what a geodesic is. That's all. Thank you.
A geodesic is a curved line. It is not straight.
Absolutely.
And in terms
Only a
of
straight line can be a straight line.
yeah, in terms of this why the moon thing, it sounds like they're manufacturing the context for which to fake another moon landing.
Yeah, it
Or they're
seems
being-
like it. Oh, there was one other
Or they're
thing,
just
by the
being
way.
open.
In the last several days or whatever, I don't know if you guys have seen this. It seems like there's multiple places who have had headlines.
Looks like there might be an error. It says excellent connection, but it says an error happened. Oh shit. Well, if the recording is still going, or if YouTube is still going, we will see you tomorrow. Thank you for watching the show. It looks like everything crashed. All right. I will see you guys later. Thank you very much again. Thank you to Kango24, Swamp Boy 34, Lael, and really appreciate it. Bye, guys.